Good evening. Welcome for today's session. If audio and video is clear, I request the students to just raise the hand so that we can start our session for today. If audio and video is clear, I request the students to just raise the hand so that we can start our session. Okay. Now in the yesterday's class, we have started economic aspects. Yesterday's class we have started economic aspects. That was the last topic that we have discussed in the last class. Now let us just go through that and start our discussion for today. So we have defined what we mean by economic aspect in the last class. So if we observe the power system network, it is operated from three utilities, mainly power generation, transmission, followed by distribution. So the consumer who is connected to the distribution end will be satisfied if the quality of supply is being provided and the cost per unit that is being minimum. So economic aspect is nothing but what? Minimizing the cost per unit given to the consumer. So sorry, by minimizing the cost of generation. If you minimize the cost of generation, automatically the cost per unit that is given to the consumer can be minimized and the consumer will be satisfied. Okay. So in order to minimize the cost per unit of generation, let us consider the load factors and diversity factors that we have analyzed in the last class. So we have defined what we mean by connected load and installed capacity. Connected load is nothing but the sum of the ratings of all the electrical equipments which are connected in the consumer premises. And installed capacity is nothing but the sum of the ratings of generators which are connected in the same bus bar. And we have defined maximum demand or maximum load. It is nothing but it is the highest amount of power consumed by the consumer or delivered by the generator for shorter duration of time. Reserve is nothing but difference of installed capacity and maximum demand. If reserve capacity is positive, we can say that the system is stable. If it is zero, it is critically stable, and it is negative means it is unstable. So we have calculated the average load, how to given the relation, and we have seen load factor. It is a ratio of what? Average load by maximum demand. So for the cost per unit to be minimum, the load factor and diversity factor should be high. So if the load factor is high, it shows that the running cost is being minimized. And if the diversity factor, it is nothing but the ratio of sum of individual maximum demands to the simultaneous maximum demand on the station, it should be also high. So if diversity factor is high, it shows that the rating of the machinery or generator will be reduced so that fixed cost will be reduced. Cost of generation is minimized. So we have gone through these aspects in the last class. Now let us continue our discussion for today. So now let us define what do you mean by demand factor. Demand factor means what? So we have seen some basic definitions in the last class. Demand factor is nothing but it is a ratio of demand factor is ratio of maximum demand to connected load. So demand factor is the ratio of what? Maximum demand to connected load. So how do we calculate the demand factor? So It is the maximum demand by connected load. As we know that the connected load will be greater than the maximum demand. Connected load is greater than the maximum demand. So the demand factor value will be less than 1. Demand factor value will be less than 1 because here the connected load will be more when compared to what? Connected load will be more when compared to maximum demand. Okay. So demand factor is nothing but it is a ratio of maximum demand to connected load. Now next, let us define plant capacity factor. Plant capacity factor. How do we calculate the plant capacity factor? What do you mean by plant load factor? It is a ratio of average load by maximum demand. It is a ratio of average load by maximum demand is what? Plant load factor. Now what do you mean by plant capacity factor? How do you calculate plant capacity factor? So plant capacity plant capacity factor is the ratio of what? Average load to installed capacity. Average load to installed capacity. Installed capacity. So now let us analyze how can we calculate the plant capacity factor, PCF. How do we calculate the plant capacity factor? That is nothing but the ratio of average load to installed capacity. Installed capacity. So how do we calculate the average load, sir? How do we calculate the average load? In the last class, I have given the relation for average load. So how do we calculate the average load? Average load is nothing but total number of units. Total number of units generated. Total number of units generated by total time. Total time over specified duration. Over specified duration. So this is the formula for what? Average load. And in the denominator, additionally, we have what? Installed capacity. Installed capacity. Okay. In the denominator, additional term we have is installed capacity. So the total number of units, we can write this plant capacity factor as. You can also write plant capacity factor as. So here total number of units generated by the maximum possible number of units that can be generated. Maximum possible number of units that can be generated. Okay. Total number of, or we can also say actual number of units. Actual number of units generated by maximum possible number of units that can be generated. That can be generated. So this is the plant capacity factor. Now, your plant capacity factor will be less than 1 or greater than 1. Plant capacity factor will be less than 1 because the unit will not run for the total duration. No? So it will be shut down for certain duration. This is about plant capacity factor. Now let us define one factor which is known as operation factor. So here we have defined plant capacity factor. So what do you mean by plant capacity factor, sir? It is the ratio of average load to installed capacity. Average load to installed capacity. Which will be more? Average load or installed capacity will be more. Installed capacity will be more than the average load. Okay. So plant capacity factor will be less than 1. Plant capacity factor is less than 1. Okay. So we can define operation factor. What do you mean by operation factor? How do you calculate the operation factor of a unit? How do you calculate the operation factor of a unit? Operation factor is nothing but it is a ratio of the service hours which the unit has been done to the total duration. So how do you calculate the operation factor? Operation factor OF, we can write it as a ratio of service hours. That means that a unit has done to the total duration. Total duration of time. Okay, that is nothing but operation factor. Okay, and we can calculate plant use factor. How do you calculate plant use factor? Plant use factor. Use factor. So how do you calculate this plant capacity factor here? Plant capacity factor is actual number of units that are generated by total time over specified duration. Total time over specified duration you have taken. Here total time is, if you are calculating daily, you should take 24 hours for a daily calculation. And suppose if you are calculating annual, 8760 hours for annual duration. Annual duration you can take it as 8760 hours. Okay, but if you are going for plant use factor, in case of plant use factor, what you will do, we will calculate only for the units, the number of hours that the unit has run. The units has run. Plant use factor is equal to plant use factor is equal to total number of units generated, total number of units generated, total number of units generated by plant capacity, plant capacity multiplied with here service hours. That means hours you need to take. That means what are the hours that actually the unit has run in operation, that is known as service hours. So for calculating plant use factor, you need to consider the service hours in the denominator, and for calculating plant capacity factor, you need to calculate what total time over the specified duration you need to consider. Total time over specified duration you need to consider. Okay. Now next we need to define one more factor, that is plant utilization factor. Plant utilization factor. Plant utilization factor. So how do you calculate this plant utilization factor? You can name it as PUF. It is nothing but it is a ratio of maximum demand to plant capacity. Maximum demand to plant capacity. The plant utilization factor is the ratio of maximum demand to plant capacity. So we have defined these terms. So what you have defined here, we have defined what you mean by demand factor. Demand factor is what? It is a ratio of maximum demand to connected load. Demand factor is a ratio of what? Maximum demand to connected load of the system. Connected load will be greater than the maximum demand. Okay, that's why demand factor is always less than 1. Okay. Next, we have defined what we mean by plant capacity factor. Plant capacity factor. Plant capacity factor is the ratio of what? Average load to installed capacity. Or you can also calculate it as actual number of units that are generated by maximum possible number of units that can be generated. It will be less than 1 because the unit will not run for the total entire duration. No, entire duration will not run the unit. Operation factor we have defined, that is service hours. That means actual time the unit has run. Okay, unit has run for the service hours, okay, by total duration. Plant use factor. How do you calculate the plant use factor? Total number of units generated by plant capacity into service hours. Here you should take service hours into consideration. Okay. Plant utilization factor is the ratio of maximum demand by plant capacity. Now we have defined plant load factor. Plant load factor is nothing but average load by maximum demand. Plant load factor is what? It is the ratio of average load by maximum demand. And plant capacity factor is nothing but average load by installed capacity. And the plant utilization factor, PUF, plant utilization factor, how do you calculate? Maximum demand by plant capacity. Maximum demand by plant capacity, or you can also say it as installed capacity. Plant capacity or installed capacity, we can say. Okay. Now, what is the relation between these three? Can you write a plant capacity factor is equal to plant load factor into plant utilization factor or not? What is plant load factor? Average load by maximum demand. What is plant utilization factor? Maximum demand by installed capacity. This maximum demand gets cancelled. Can I write it as average load by installed capacity or not? Yes or no? Can we write it or not? Yes. Okay. So the relation between the plant capacity factor, plant load factor, and plant utilization factor is, understood my point? Here the plant capacity factor and plant utilization factor, the PCF and PUF are useful. What is the purpose of this calculation of plant capacity factor and plant use factor? Suppose if you have 200 megawatt generator, suppose you have 200 megawatt generator. Now you have to enhance the existing system. That means you want to upgrade the existing system. For how much power that you need to upgrade? What is the enhancing capacity that you need to add up? That is decided by what? Plant capacity factor and plant utilization factor or use factor. These factors, these factors are useful, are used for enhancing the existing system capacity. That means how much capacity to be added up to the existing system, that can be decided by what? Plant capacity factor and plant use factor or utilization factor, we can say. So now let us take one problem. Let us take one problem based on this. Let us take one problem. If the problem is given like this, if the connected load, if the connected load is 23 megawatt. Connected load is how much? 23 megawatt. Maximum demand in the station is some 20 megawatt. Connected load is 23 megawatt. Maximum demand is 20 megawatt, and number of units generated. Number of units generated is 61.5 into 10 power 6 units per annum. These are number of units generated per annum. Now here try to calculate what is the demand factor. You try to calculate, and what is the average load of the system, and what is the load factor. So calculate the demand factor, average load, and load factor. So how do you calculate the demand factor, sir? So he has given the connected load. He has given the connected load, maximum demand, and number of units that are being generated. Now, how do you calculate the demand factor? Demand factor, solution for A. So, how do you calculate the demand factor? Factor is the ratio of what? Maximum demand to connected load. Maximum demand to connected load. Maximum demand to connected load ratio. So what is the maximum demand given here? 20. Connected load is how much? 23. So how much? What is the demand factor, sir? Here, what is the demand factor? Post the answer. Calculate demand factor and post the answer. 0.869. 0.869. Okay. Now let us go for the next question. In the second question, what is asking to calculate? Average load. So how do you calculate the average load? Average load is nothing but total number of units generated, generated by total time over specified duration, over specified duration, Okay. So what is the total number of units that are generated given? 61.5 into 10 power 6. 61.5 into 10 power 6. So this is the total duration. What is the here per annum given? Here observe here annual, the annual value is given. So annual number of units that are generated given. So that is 24 into, we can say it as 365 days. So what is the average load? Calculate and post the answer. What is the average load, sir? What is the average load? Calculate and post the answer. Hours will not be there, sir. Observe. Hours will not be there. 1 unit is 1 kilowatt hour. Huh? How much? How many kilowatts? So So here you'll get the average load as 7.020 kilowatt. Yes or no? This is in kilowatt, no? Kilowatt. So that is a kilowatt if you can express like this. Here seconds will not be there because number of one unit is 1 kilowatt hour. No, one unit is 1 kilowatt hour. Okay, here you will have a unit of kilowatt. So this one unit is 1 kilowatt hour. So one unit means one unit is 1 kilowatt hour. One unit is 1 kilowatt hour. Okay, so now here and total time is in hours. So this will get cancelled out. We will left over with this. Now what about load factor? So how do you calculate the load factor? Load factor is what? Load factor. Third question is asking to calculate the load factor. Load factor is the ratio of average load by maximum demand. So what is the average load that you got here? 7.020 kilowatt. 7.020. And what is the maximum demand given? 20. Maximum demand given is 20. So what is the load factor? Calculate and post the answer. What is the load factor? 0.351. 0.351. So this is how here in this question what is asking to calculate connected load given, maximum demand given, number of units that are generated given. Is asking to calculate demand factor, load factor and average load. We know the relations and we got this. Okay, right. So once we have the idea about this basic factors, now let us define some aspects regarding the generation units. So what do you mean by load curve? Now how can I define load curve means what? Load curve. So what do you mean by load curve? And a load curve gives what? Load curve gives what? Now let us analyze. Load curve is nothing but it is a curve which shows the variation of power in kilowatt with respect to time. It shows the variation of load with respect to time. Load curve is nothing but it is a curve which shows the variation of load with respect to time. Load is constant or variable. Load is constant or variable. Load is a continuously variable parameter. Load is a continuously variable parameter. If you are drawing for 24 hours, it will be a daily load curve. Daily load curve. And if you are drawing for monthly 24 into 30 days, or if you are drawing for 8760 hours, it will be an annual load curve. So from daily load curve, you can get monthly load curve. From monthly load curve, we can plot annual load curve. So what is the load curve? How can I define load curve? Load curve is nothing but it is a curve which shows the variation of load with respect to time. It is a curve which shows the variation of load, the variation of load with respect to time, with respect to time. It is a curve which shows the variation of load with respect to time. Okay. So what does this load curve gives? What data you can obtain from the load curve? Okay, what data you can obtain from the load curve? The highest point on the load curve, the highest point on the load curve is known as maximum demand or maximum load. Maximum demand or maximum load. Or the highest peak, you can calculate the maximum load or maximum demand. So load curve gives what? So what data you can obtain from load curve? From the load curve, we can calculate first one is the highest point on the load curve gives what? Maximum demand or maximum load. Okay. The highest point on the load curve, the highest point on the load curve, gives maximum demand. Maximum demand. on the station. And by using this load curve, if you can calculate the area occupied by this load curve, if you can calculate the area occupied by the load curve, so what does this area occupied by the load curve gives? Area occupied by the load curve gives what? The total number of units that are being generated. Area occupied by the load curve gives what? Total number of units generated. Total number of units generated is equal to what? Area under the load curve. Area under the load curve gives what? The total number of units that are being generated. Okay. So the second point that you can obtain is area under the load curve. Area under the load curve gives total number of units generated. Total number of units generated. So if you can calculate the area under the load curve, we can calculate how many number of units that are being generated. Okay. Now if we observe, we got the maximum demand, and the total number of units that are being generated. So now can you calculate the average load or not? From this, can you calculate the average load? Can you calculate the average load? Average load is nothing but once you calculate the area under the load curve, you get the total number of units that are generated and total time over specified duration. Total time over specified duration. Specified duration. Okay. Area by total time over specified duration gives the average load. Once you calculate the average load, can you calculate a load factor? Can you calculate load factor or not? Load factor is nothing but average load by maximum demand. Average load by maximum demand. So we calculated the average load and we calculated the average load and we calculated the maximum demand. Highest point on the load curve gives what? Maximum demand. Highest point on the load curve gives maximum demand. Yes or no? And average load is calculated. So we can calculate load factor also by using this load curve. And still, what we can calculate by observing this load curve, we can we can calculate what is the load at that respective point of time. Okay, we can calculate or we can be able to know what is the load. We can know the load at that specified time at a specified time. Load at that specified time can be obtained by using this load curve. Okay, so load curve is nothing but it is a curve which shows the variation of load with respect to time. So we can obtain all this data. That is, the highest point gives the maximum demand. Area under the load curve gives the total number of units that are generated. Average load, area by total time or specified duration gives the average load. Load factor can be calculated. We can know the load at specified time or at any interval of time by using this load curve. Okay. Now, here, once there was a question asked in exam, load curve will have positive slope, negative slope, or zero slope. Load curve will have a positive slope, B negative slope, C zero slope, or all above. Okay. So this was the question asked. Load curve will have the positive slope, negative slope, or zero slope, or all the above. So load curve will have what? So observe the load curve here. So it may have either positive slope. In this region, if you observe, it has a positive slope. At this point, it has zero slope, and at this point, it has negative slope. So the load curve may have either positive slope or negative slope or zero slope because the load is not constant. The relation of load with respect to time is load curve. It is not constant. So it is not a constant. So here we have zero slope. Here we have zero slope. Okay. And here we have the positive slope. Here we have the positive slope. Here we have the negative slope. Here we have the negative slope. So positive slope, negative slope, and zero slope. Okay, understood my point? And there was once question asked, which plant will have zero slope load curve? So generally, he has given the characteristic of the load curve like this: variation of power with respect to time. He has given which plant may have this type of characteristic. So which plant may have this type of characteristic? Just wait. So A nuclear, B thermal, C tidal plant, and D gas plant. So this type of load curve with zero slope. Generally, the zero slope load curves are possible in case of nuclear plants. Okay, nuclear plants may have zero slope load curve because controlling the nuclear reaction is difficult. Whatever the power that is generated will be delivered to load. Understand my point? The bottommost portion of the load curve is occupied by what? Nuclear plant. That is allotted to nuclear plant. Understand my point? The bottommost portion of the load curve is allotted to nuclear plant. Okay, generally nuclear plants have zero slope zero slope load curve because controlling nuclear reaction is nuclear reaction is difficult. So bottommost portion of the load curve, if you observe the load curve, the bottommost portion of the load curve is allotted to what? Nuclear power plants only. So whatever the power that is generated is being delivered to the load. So controlling the nuclear reaction is difficult. So answer is what? Nuclear power plant may have zero slope load curve. Understood my point? Now let us define what do you mean by load duration curve. Load duration curve. Load duration curve means what? So how can you define load duration curve? So here the load curve is what? Load curve is what? It shows the variation of load with respect to time. Load curve shows variation of load with respect to time. Load duration curve is nothing but it shows the variation of load with respect to percentage of time where the loads are arranged in the descending order. Okay, so load duration curve, what does load duration curve shows? It shows it shows the variation of load with respect to percentage of time where loads are arranged in a descending order where the loads are arranged in descending order. So load curve shows what? It shows the variation of load with respect to time. But here load duration curve shows the variation of load with respect to percentage of time where the loads are arranged in descending order. Here the loads will be arranged in the descending order with respect to percentage of time. This is the load duration curve. Here, area under the load duration curve also gives the total number of units that are being generated. Area under the load duration curve also shows what? The total number of units that are being generated. Here, the loads are arranged in what? Descending order. Area under load duration curve gives what? Number of units generated. Now we have seen, and the highest point gives the maximum demand. The same whatever the data that you get here also you can directly obtain in case of low duration curve. Now, if the problem is given like this, if the question is given like this, suppose the question is given like this, problem is given. Load duration, the annual load duration curve is shown below. is shown below. Calculate first one, maximum demand you calculate. Second one is number of units generated. Number of units generated you calculate. Third one, average load you calculate. Average load you calculate. Fourth one is load factor. Load factor you try to calculate. So the load duration curve is given like this. The load duration curve is given like this. Variation of power with respect to time. Here power in kilowatt that has been given. So here the load duration curve is like this. This is 300 kilowatt and this is percentage of time. Annual load duration curve is given. So try to calculate what is the all the values here. First one is maximum demand. First one is what is asking maximum demand. Maximum demand you try to calculate number of units generated, average load, load factor. Calculate all these values. Try to calculate all these values. Calculate all the values. So how do you calculate maximum demand? The highest point on the load duration curve gives the maximum demand. So maximum demand is what? 300 kilowatt. Maximum demand is 300 kilowatt. Option B. Sorry, second question. What is asking to calculate? This is in terms of option. So here the first question is asking maximum demand. Second question, number of units generated. Number of units generated. How do you calculate the number of units generated? From the given data, number of units generated can be calculated by what? Area under load curve. Area under load curve. Here, how do you calculate the area under load curve? This is a triangle. Half into base into height. Base is what? Annual duration. That is 8760 hours. Here annual duration, annual given 8760 hours into 300. So this will give the total number of units that are being generated. Okay. Next, third case, what is asking? Third case, what is asking to calculate? Average load. Average load, how do you calculate? Total number of units that are generated. Half into 8760 into 30 by total time or specified duration. 8760. So how much you get? Average load is how much? 300. No? So average load is how much? 15. Sorry, 150 kilowatt. Average load is 150 kilowatt. So once you know the average load, can you solve the fourth one or not? Fourth question, load factor. Average load by maximum demand. Average load is 150, maximum demand is 300. How much? 0.5. Just wait a minute, sir. So sorry for disturbance. So here he's asking to calculate what? Load factor. Load factor is 0.5 or you can also take it as 50%. 50% also you can write. So I think you have all got the idea how to calculate maximum demand, number of units that are generated, average load and load factor. Okay. Now, let us take one more problem. I will give, try to solve this. Problem is given like this. Calculate load factor, calculate load factor, annual annual load duration curve, annual load duration curve is given. Annual load duration curve is given. He is asked to calculate the load factor. So he has given the variation of power in kilowatt with respect to time, percentage of time he has given. So the annual load duration curve is given like this. This is some 400 kilowatt and this is some 200 kilowatt. And, this is the annual load duration curve. He is asking to calculate the load factor. Try to calculate the load factor and post the answer. Try to calculate the load factor and post the answer. Try to calculate the load factor, sir, and post the answer here. So load factor is what? How do you solve here? How do you calculate the load factor? Load factor is the ratio of what? Average load by maximum demand. So what is the maximum demand here that you can calculate is 400. Highest point, that is nothing but highest point is 400. So that is the maximum demand. Now how do you calculate the average load? Average load is nothing but average load is nothing but area under the load curve by total time. Total time over specified duration. Over specified duration. So area under the load curve by area of load curve by area under the load curve by total time over specified duration. So what is the area under the load curve? How do we calculate? Here there are two. One is a triangle is there and the other one is rectangle. So one is a rectangular area is how much? This is 200 length into breadth. This is 8760 hours. Plus this triangular area half into base is 8760. Yeah, sorry. 8760 multiplied with height. Height is how much here? 200. Height is 200. By total time our specified duration is 8760 hours. 8760 hours gets cancelled here. 8760 gets cancelled. So how much here you get? 200 plus this 100. So what is the average load here? 100 or no? 200 plus 100. 300 kilowatt is the average load. So once you know this average load and maximum demand, load factor you can calculate. Average load is how much here? 300. Maximum demand is 400. So how much do you get load factor? Calculate and post the answer. Load factor, how much do you get? Load factor. So this triangular area you should not take this one. This is only 200. No, you should consider this area. So half into base is 8760, height is 200, and this rectangle base into length into breadth. Right. So how much, sir? Load factor calculated. Load factor how much? 0.75. 0.75 or 75%. 0.75 or we can say it as 0.75 or 75% is the load. Understood my point? So this is how you need to calculate load factor from the given load duration curve, and average load and total number of units that are being generated can be calculated by using this relationship. Now let us go for the next topic, that is how do you define firm power. So firm power means what? Firm power. So what do you mean by firm power? So how can you define firm power? Suppose if you are running a generating unit, if you are running a generating unit capacity is some 200 megawatt. It is generating 200 megawatt and the power is delivering to load. Suddenly there is some problem in the unit. Unit has experiencing some problem in the mechanical section, suppose, and the unit has shut down and the unit has come to stall condition. There is no power generation now. So for repairing the unit, you require illumination or not? For repairing the unit, we require what? Illumination, yes or no? For repairing the unit or for using any auxiliaries, for using the equipment for repairing the unit done, we require some power. The from where do we get that power? So that is known as firm power. Firm power means the power which is available even during emergency conditions is known as what? Firm power. So how can I define firm power? The power which is available, which is available even during emergency conditions. Emergency conditions is known as firm power. Is known as firm power. So the power which is available even during emergency conditions is known as what? Firm power. What is the example? What is the source of this firm power? Suppose energy lamps, or we can say backup generators or backup diesel engine driven generators. So by using this, we can provide the illumination and we can drive some instruments for repairing the unit. Okay, that is the meaning of firm power. Okay, now let us define the other term which is known as hot or cold power. Let us define first. So what do you mean by cold power? Cold power means what? Cold power means what? Suppose if you have two units, if there are two units, each rated is some 200 megawatt. Each rated is some 200 megawatt. So suppose this circuit breaker is closed, and this is also 200 megawatt, and this is some 150 megawatt generator. One is 200 megawatt generator, and the other is 150 megawatt generator. Now what happened? This unit is under repair. The mechanical input is zero. There is no mechanical input given. But here the mechanical input is not zero, and it is delivering power to load. Circuit breaker is closed. But here circuit breaker is open. This unit is under sick condition. This unit is under sick condition, or you can say it as repair condition. The unit is under repair condition. So the power rating of this generator is known as what? The power rating of the generator is known as cold power. That is known as what? Cold power. So what do you mean? How can you define cold power? Cold power is nothing but it is the amount of power. It is the amount of power which it is the amount of power which is not in operation, which is not in operation, but it can be made into service. It can be made into service by repairing the unit, by repairing the unit by repairing the unit, we can go for what? We can make that into service. That is known as what? Cold power. If that unit is sick or a repair condition, by repairing that unit, we can make that unit into service condition. That is known as what? Cold power. So here cold power is how much? 150 megawatt. Understood my point? Cold power is 150 megawatt. Now let us define the hot power. Let us define the next term, that is hot power. What do you mean by hot power? Suppose if you have three units, suppose if you have three units uh, which are connected to this bus bar. Now Here the first unit, suppose if you consider like this, first unit circuit breaker is open. Circuit breaker is open. There is no mechanical input. There is no mechanical input. Mechanical input is zero. So the unit is under sick condition or a repair condition. The unit is under sick condition or repair condition. Suppose this rated is 200 megawatt. This 200 megawatt comes under what condition? Cold power. This 200 megawatt comes under cold power condition. Suppose if you consider a case like this, here the circuit breaker is open. Circuit breaker is open, but mechanical input is provided. Mechanical input is provided. Mechanical input is not zero. Mechanical input is provided here. Mechanical input is being provided, but it is not delivering any power. And the other generator here, P mechanical is not equal to zero, and here the circuit breaker is closed. The circuit breaker is closed. Okay. So, and it is delivering the power. Now, what about this second unit? What about this second unit? Suppose this is also 200 megawatt, and this is also some 200 megawatt. 200 megawatt. So, what do you mean by hot power here? What do you mean by hot power? How can you define hot power? How can you define a hot power? Hot power means what? So here the amount of power which is in operation but not in service. Here it is not delivering any power to the load. But here the unit is under on condition. Unit is under on condition. That is all the auxiliaries are running, mechanical input is given. Minimum mechanical input is being given. So that is known as what? Hot power. So how can you define hot power? It is the amount of power. It is the amount of power. Amount of power which is in operation, which is in operation, which is in operation, but not in service, but not in service. It is the amount of power which is in operation but not in service is known as what? Hot power. It is the amount of power which is in operation but not in service is known as hot power. So this unit is under what condition? Hot condition. This unit is under hot condition. That means 200 megawatt is under hot condition. We can say that. Okay, 200 megawatt is under hot condition. We can say. What is the need of keeping the unit under hot condition? Now our question is why we need to keep the unit under hot condition. Okay, why the unit is to be kept under hot condition? The reason may be like this. For normal start, if the boiler has not initiated its flame, for normal start, thermal power plant takes 8 hours to start. Okay, for normal start, thermal plant takes how much time? 8 hours. So during this 8 hours, what happens? The load will change its characteristic. You cannot meet the present load requirement if you are keeping the unit under complete shutdown condition. So that's why we will keep the unit under what condition? Hot start condition. Okay. So for normal start, for normal start, the thermal plant takes approximately 8 hours. 8 hours. Okay. During this time, load changes its load changes its characteristic. That means load will not be same as we have predicted. So to avoid this, to meet the load requirement, it is preferred to keep the unit under what condition? Hot condition. To meet the load requirement, it is preferred to keep. It is kept under what condition? Kept under hot start condition. Hot start condition. Hot start condition means mechanical input is provided and all the accelerators are running, but it is not delivering any power. Minimum mechanical input is provided to overcome the losses. That's all. So, and it is not delivering any power here. Circuit breaker is open only. Whenever the load requires the power, just we synchronize this alternator to grid and it will deliver the power. That is known as what? Hot start condition. That is known as hot start condition. So hot start takes approximately 15 minutes. Okay. Hot start takes around 15 to 20 minutes. 15 to 20 minutes. So during that 15 to 20 minutes, you can make it up to the load requirement. So, but if you are going for normal start in case of thermal plants, it is not preferred because it takes more time. What is the synchronizing sequence? Which plants synchronize fast? So fastest synchronizing plant is gas. Gas plant will have the fastest synchronizing plant because synchronized time will be less. Next to gas, hydel. Next to hydel, nuclear. Next to nuclear, thermal. Okay. This nuclear also takes approximately 8 hours. This thermal also takes approximately 8 hours. But we will not keep the nuclear plant under hot start condition because controlling the nuclear reaction is difficult. Okay. Fastest synchronizing plant is what? Fast synchronizing plant. Fastest synchronizing plant is gas plant. That's why it is preferred to use as a peak load plant because the peak load exists for only shorter duration. Peak load exists for only shorter duration. During that interval, it should turn on and it should meet the load requirement. It should turn on and it should meet the load requirement. Okay, understood my point here. Okay. Fastest synchronizing plant is fast synchronization plant is plant is gas plant. Fastest synchronization plant is a gas plant. So hence it is preferred to use it as what? Hence it is preferred preferred to use as peak load plant. Peak load plant. Peak load exists for only shorter duration. Peak load exists for only shorter duration of time. Okay, during that time, this plant has to run and it should meet the load requirement. And here, nuclear also takes approximately same time as thermal plant, but nuclear is not preferred to kept under hot start condition because controlling the nuclear reaction is difficult. So we have defined what do you mean by firm power, what do you mean by cold power. Firm power means what? It is a power which is available even during emergency conditions is known as what? Firm power. Next we have defined what we mean by cold power. It is amount of power which is not in operation but it can be made into service by repairing the unit. Suppose if that unit is under repair condition, that comes under cold unit. Hot power means mechanical input is provided but it is not delivering any power to grid or load. So here why the unit is kept under hot start condition? Because synchronization time will be more if you go for normal start. That's why we'll keep the unit under what? Hot start condition. Now let us define what do you mean by spinning power. Spinning power. Spinning power means what? Spinning power means suppose it is nothing but it is the amount of power available at the bus bar and it is delivered to load and consumed by the load, that is known as what? Spinning power. Okay, spinning power means it is the amount of power available at the bus bar and delivered to load. It is the amount of power is the amount of power available at bus bar. It is the amount of power available at bus bar and delivered to load. It is the amount of power available at bus bar and delivered to load is known as spinning power. Is known as spinning power. It is known as spinning power. So we have defined these four terms. Now let us go for what do you mean by, just wait sir. Now sorry for discussion. Now let us define what do you mean by Economic load dispatch. We have completed economic aspects. Now let us go for economic load dispatch. So, economic load dispatch. So what do you mean by economic load dispatch? Let us analyze like this. Before going to economic load dispatch, first let us learn what do you mean by preload dispatch or unit commitment. What do you mean by preload dispatch or unit commitment? Unit commitment problem. So what do you mean by preload dispatch or unit commitment problem? Suppose if you are planning for a tour like this, we can analyze like this. If you are planning for a tour for 10 days, so total number of members on your for your home, suppose if you are 50 members, if you are having 50 members planning for a tour of 10 days, so what you need to do, what do you need to do? First, you need to preload that. Preload, or you should commit the status of the vehicles. Yes or no? For 50 members, suppose each vehicle 10 members, each bus, mini bus, 10 members. Suppose you should select how many buses? 5 buses. So how do you select that 5 buses? That 5 buses should be in what condition? Good condition. If the bus condition is not good, will you select that bus? No. So we should optimally select. We should optimally select the buses from the available buses. More number of buses are available in the market. You should not select all the buses. No, only the buses which are only the buses which are in good condition you should select. And the other one is economics is also important. Good condition, high cost. Will you prefer to take to tour? No. Yes or no? Okay. Will you take Mercedes Benz bus to your tour? Okay, you cannot afford that. No? That economics is also important. What you need to do, we should optimally select the buses so that good condition, so that it meets the load, that is load requirement it will meet, and cost should be also minimum. Cost should be also minimum. That is known as preload dispatch. So first, what you'll do, you'll do the planning. You'll search in the market and you'll select the optimal number of buses from that to meet your load requirement. To meet your load requirement. That is known as what, preload dispatch. Here, the load is in terms of power. Okay. So what do you mean by preload dispatch? So selecting the optimal number of generating units, selecting the optimal number of generating units from the available healthy units. From the healthy units you need to pick up so that it will meet the demand, power demand, along with certain reserve. It will meet the demand along with certain reserve capacity is also to be considered, because day by day the load is increasing. Day by day the load is increasing. No, load is increasing. It's a nature. Okay, to meet that increased load, we will select with certain reserve. Okay, what load dispatch center does? Load dispatch center says that tomorrow your generating station should generate this amount of power. How they will know that tomorrow's load forecast? How they will forecast your load? Previous year load curve data is the basis. Previous years today, what is the load curve, load on the particular load curve data? They will take that, and along with that power with certain reserve, additional reserve they will add up, and they will schedule the load. Okay, that is known as what, preload dispatch or unit commitment. For tomorrow's meeting of load, today they will plan the generating units so that they will inform the generating units that tomorrow from this time to this time you need to meet this load. That means you need to generate this amount of power. So that is nothing but preload dispatch or unit commitment. That is nothing but what, preload dispatch or unit commitment. So how do you define preload dispatch or unit commitment? Selecting selecting optimal optimal number of generating units, optimal number of generating units from from the from the available healthy units, from the available healthy units to meet the power demand, to meet the power demand along with along with certain reserve, certain reserve. So generally reserve will be 10%, 10% along with certain reserve such that such that fuel cost is minimized. Fuel cost is minimized. So you should not select high cost buses no to meet your to go for a low your tour. You're based on your what do you say your economical condition. You should select the bus for your tour. Here also the same. Select optimal number of generating units from the available healthy units. More number of units are there, but from that you should select healthy units to meet the load requirement along with certain reserve, such that fuel cost is minimized. What is the objective of unit commitment here? Objective of unit commitment. Unit commitment problem is what? What is the objective? It will give the commitment status of the units. That is, if the unit is committed for generation, U is equal to 1. If U equal to 0 is indicated means not committed. Okay. It will give the committed status of the units. So what the load dispatch center says, calls the particular generation company and says that tomorrow you should generate this amount of power from this time to this time. So if they says okay, then the unit will be committed for generation. Okay. So they should prepare for that. They should prepare for that. That is nothing but preload. Preload dispatch or unit commitment. And what is the other objective? Fuel cost is minimized. Minimum fuel cost. Minimum fuel cost. Our problem here is optimization of the fuel cost. Here our problem is optimization of fuel cost. Optimization of fuel cost is the problem. Okay. So what do you mean by preload dispatch or unit commitment problem? Select optimal number of generating units from the available healthy units to meet the power demand along with certain reserve, such that fuel cost is minimized even as what? Preload dispatch or unit commitment. Once the preload dispatch is completed, now tomorrow what we need to do? Whatever the available units that are being selected for commitment that are committed, you should allot the existing load. You should allot the existing load to the selected units. To the selected units. That is known as online dispatch or economic load dispatch. What do you mean by economic load dispatch? Economic load dispatch or online dispatch or online dispatch. So what do you mean by economic load dispatch or online dispatch? So now once we have committed today we have prepared all the buses. We have gone to the market and we have paid advance to all the buses to go for tour from tomorrow onwards. Tomorrow what you should do? You should distribute that 50 members to all the buses. Okay, such that your tour is successful. Yes or no? Okay, now here also online dispatch means what there 50 members is constant, but here our load is not constant. Load is a continuously varying parameter. Yes or no? So whatever the load that has been existing at that time, that is to be allotted to the committed units, such that the cost is minimized, such that the fuel cost is minimized. So what do you mean by economic load dispatch now? What do you mean by economic load dispatch? Allotting the existing load, allotting the existing load to the to the committed units, on time to time basis, on time to time basis, so that so that fuel cost is minimized. So on the committed units, you have hydel plants, nuclear plants, and thermal plants, and suppose gas plants also. So in hydel plants, there is no cost. There is no cost. Cost will not be there. So what you do first, until the hydel plant is completely loaded, we will allot the load to hydel plant, so the cost is reduced. Fuel cost is to be minimized. Objective is to minimize the fuel cost. So what is the output of this economic load dispatch? Objective is what? Objective is It will give the power output of generators. It will give the power output of generators. Here what it will do? Here power output of generators. Power output of generators. That means how much power it should generate. Power output of generators is given by this economic load dispatch. That means generator 1 should generate how much, generator 2 should generate how much power. Like that, nth generator should generate how much power. That is given by this economic load dispatch problem, and it will also minimize the fuel cost. Fuel cost. We should minimize the fuel cost and we should generate the power. How much power is to be generated? That is done by economic load dispatch problem. So we have defined what do you mean by preload dispatch. Preload means pre. Pre means before going for meeting the load, you need to schedule that. That is done by what? Preload dispatch. You should select optimal number of selected units from the available healthy units to meet the demand along with certain reserve. Reserve is required because day by day load is changing, and to meet that variations in the load, we need to take that consideration. Okay. So once the preload dispatch is completed, now comes to the online dispatch problem. So whatever the existing load is there, that load is to be allotted to the committed units on time to time basis. So that the fuel cost is minimized. That is known as what? Economic load dispatch or online dispatch problem. Okay. Now let us see how to go for this minimization of fuel cost. How can you minimize the fuel cost? So if you consider the thermal power plant, in order to minimize the fuel cost, you should know the fuel cost equation. You should know the fuel cost equation. If you observe the thermal power plant, fuel input is given to boiler. Fuel is given as input to boiler. Boiler output is what? Steam. Boiler output is steam. Steam output steam. Boiler output is steam. So the steam is given as input to what? Turbine. The steam is given as input to turbine. The turbine and rotor of the generator are mechanically coupled, yes or no? Turbine and this generator are mechanically coupled. Turbine and generator are mechanically coupled. Here, power that has been generated. Now, how do you relate this fuel cost? We should build the relation between this fuel cost and power generation. We should relate we should get the equation is to be formed between the fuel cost and power that is to be generated by the generator. That is known as fuel cost equation. That is known as what? Fuel cost equation. So what is the fuel cost equation in case of thermal power plant? Now let us see fuel cost equation in case of thermal power plant. So how do you write the fuel cost equation? This is an empirical formula. There is no derivation from that. So based on the input output characteristics only, this has been derived. Okay. So there is no derivation for that. So what is the fuel cost equation? That is given like this. F. This fuel cost equation is a fuel cost is a function of power generation. F of Pg equal to half alpha Pg square plus beta Pg plus gamma. Unit of fuel cost is what? Rupees per hour. Here F is what? Fuel cost. F is the fuel cost, and Pg is what? Real power generation. Generation. Real power generation. And what about alpha, beta, gamma? Alpha, beta, gamma are, these are what? Alpha, beta, gamma are known as cost coefficients. Are known as cost coefficients. Are known as cost coefficients. Okay. On what factors alpha, beta, gamma depends? On both physical and technical constraints. Alpha, beta, gamma depends on both, sir. This is physical constraints and technical constraints. Alpha, beta, gamma depends on both technical conditions. What are the physical conditions? What is the mode of transport of coal? Where the plant is located? How that coal is being transported? And what is the quality of coal? All those comes under what? Physical constraints. What about technical constraint? What is the type of plant? What is the capacity of plant? What is the technology that has been used in plants? All those comes under this technical and physical conditions. Okay. So these are the cost coefficients. Alpha, beta, gamma will not be same for all the plants. So now this is known as what? Fuel cost equation. Fuel cost equation gives what? It give fuel cost equation gives what? It gives the relation between fuel cost in rupees per hour with respect to power generation. Now, what do you mean by fuel cost curve? Fuel cost curve. Fuel cost curve. Fuel cost curve means what? Fuel cost curve is nothing but it is a curve which shows the variation of fuel cost in rupees per hour with respect to power generation in megawatt. Okay. Fuel cost curve means what? It is a curve which shows the variation of fuel cost with respect to power generation in megawatt. It is a curve. It is a curve which shows the variation of fuel cost fuel cost with respect to power generation with respect to power generated in megawatt. Fuel cost in rupees per hour with respect to power generation in megawatt. So if you observe this fuel cost equation, what do you have? Half alpha Pg square plus beta Pg plus gamma. This is the fuel cost equation. So if you plot this fuel cost equation with respect to fuel cost in rupees per hour with respect to power generation in megawatt, so how that this is a second order equation. So the curve shows like this. The curve shows like this. So there are limits on power generation. The power which is generated should be within the minimum limit and maximum limit. Why the power should be within the minimum limit and maximum limit? So if the power that is generated by the generator should be within the minimum limit and maximum limit. Why these limits are there? Let us analyze. If the power that is generated between minimum and maximum value, then only the system will be stable and economical. Okay, then only the system will be stable and economical. So there is a limits on power generation. Pg minimum less than or equal to Pg less than or equal to Pg max. So the power which is generated should be within the minimum and maximum limit. Why these limits are there? Let us analyze. Okay. So why Pg should not be greater than Pg max? Why Pg should not be greater than Pg maximum? So what is the answer for that? Why Pg should not be greater than Pg maximum? What happens if you want to generate more than its capacity? If you want to generate more than its capacity, what happens, sir? If your capacity of the generator is 200 megawatt, if you want to generate 250 megawatt by using the same generator, what happens? You should give more input, more fuel input to the boiler. Yes or no? More fuel input to the boiler. It may result in boiler explosion. It may result in boiler explosion. And whenever you are generating more than its capacity, the winding also gets heated up. Yes or no? Thermal considerations will limit the maximum power generation. Thermal considerations will limit what? Maximum power generation. Understood my point here? So why the limits are there on maximum limit? So if Pg greater than Pg max, it may result in boiler explosion, boiler explosion, um, damage of alternator or generator, etc. Okay, due to overheating, damage of alternator due to what? Overheating. Okay. So what is the constraint? So Pg should not be greater than Pg max due to thermal limit consideration. Due to what? Thermal limit consideration. Okay. Due to thermal limit is imposing this value. Okay, that about maximum value. What about minimum value? What is minimum power? What is minimum power? That is the power required to overcome the losses in the system. That is the power required to overcome the losses. Minimum power is nothing but power required to overcome the losses. If Pg is less than Pg minimum, what happens? The boiler flame will be unstable and the system will not be operating in proper manner. Okay, so PG minimum is nothing but minimum power is required to overcome the losses in the system. Okay, why PG should not be less than PG minimum? What is the reason? PG minimum is the power required to overcome what? Losses. To overcome the losses here. Okay, PG less than PG minimum. PG minimum is the power required to overcome the losses. If PG is less than PG minimum, boiler flame is unstable. Boiler flame is unstable. So that's why the power which has been generated should be within the minimum limit and maximum limit for economical and stable operation. For economical and stable operation. Okay. So we have got in case of thermal plant, the fuel input is given to the boiler. Boiler output is steam that is given to turbine. Turbine and generator are rotor are mechanically coupled. Output is real power generation. Now we need to build the equation between this fuel cost and real power generation. Okay, so the fuel that is given by the fuel cost equation. This is an empirical relation. There is no derivation for this empirical equation. So here alpha, beta, gamma are positive real coefficients or cost coefficients. We can say cost coefficients. We can say here. They depend on the physical and technical constraints of that plant. Physical means suppose if that plant is at 100 kilometers from the coal area or coal belt. From that coal belt, we need to transmit the coal. We need to transport the coal. That can be done by rail, road, means. So there the cost will change. Mode of transport will influence. Type of coal will influence that. And what type of plant it is, what is the capacity of that plant, and what is the technology of that plant. That all decides this cost coefficients. Okay. A fuel cost curve, it shows the variation of fuel cost in rupees per hour with respect to power generation in megawatt. So our objective is what here? To minimize the fuel cost. Okay. So the fuel cost equation f of Pg is what? Half alpha Pg square plus beta Pg plus gamma rupees per hour. Our objective is to minimize this fuel cost. Okay. Minimum fuel cost to be minimum or maximum? Minimum. Okay. In order to minimize the fuel cost, here fuel cost is a function of what? Real power generation. Here fuel cost is a function of real power generation. Okay. So in order to minimize the fuel cost, we need to differentiate that fuel cost equation with respect to power generation, because in maxima and minima problems we'll be studying in numericals. No, here also the same. So in order to minimize the fuel cost, in order to minimize the fuel cost, differentiate fuel cost equation with respect to real power generation, that is nothing but it is known as incremental fuel cost. That is known as what? Incremental fuel cost. If you differentiate the fuel cost with respect to real power generation, we will get incremental fuel cost. What do you get? df by dpg. So if you differentiate that, what do you get here? Alpha pg plus beta. This is known as incremental fuel cost. This is known as what? Incremental fuel cost. What is the unit here? Rupees per megawatt hour. Rupees per megawatt hour is the incremental fuel cost. Understand my point? This is the incremental fuel cost equation. So what do you mean by incremental fuel cost curve? What do you mean by incremental fuel cost curve? Okay. Incremental fuel cost curve. So what do you mean by incremental fuel cost curve? It shows the variation of incremental fuel cost. In in rupees per megawatt hour, in rupees per megawatt hour, with respect to power generation in megawatt, with respect to power generation in megawatt. That is known as what? Incremental fuel cost curve. So this curve is in a linear one, y is equal to mx plus c form. So the same limits will be imposed, Pg minimum less than or equal to Pg less than or equal to Pg max. So the power which is generated should be within the minimum and maximum limit for economical and stable operation. Economical and stable operation. The power which is generated should be within the minimum and maximum limit. So what do you mean by incremental fuel cost curve? It shows the variation of it shows the variation of incremental fuel cost with respect to power generation, with respect to power generation in megawatt. So this is incremental fuel cost curve. So incremental fuel cost means what? In order to minimize the fuel cost, objective is to minimize the fuel cost. No, differentiate that with respect to power generation. That gives the incremental fuel cost. What is the unit of fuel cost? Unit of fuel cost is rupees per hour. Unit of incremental fuel cost is rupees per megawatt hour. Understood? This is very important. Incremental unit of fuel cost is rupees per hour. Unit of incremental fuel cost is rupees per megawatt hour. Okay. So fuel cost will have the unit of rupees per hour, and incremental fuel cost will have unit of rupees per megawatt hour, rupees per megawatt hour. Suppose if the problem is given like this, I will take one problem based on this. So let us take one problem. Suppose if the question is given like this, if the fuel cost is, if the problem is given like this, if the fuel cost equation is given like this, 0.2 P1 square, 0.2 P square plus 30P plus 100 plus 30P plus 100. This is the fuel cost equation. This is the fuel cost equation. If the rated capacity, if the capacity is 200 megawatt, calculate fuel cost, fuel cost, and incremental fuel cost, incremental fuel cost, fuel cost and incremental fuel cost. If it is operated, if it is operated at 75% of capacity, at 75% of rated capacity, rated capacity. If it is operating at 75% of its rated capacity, calculate the fuel cost and incremental fuel cost. This question was given in previous exam. Okay. So how do you calculate? So what is the rated capacity given here? 200 megawatt. Okay. So PR given as 200 megawatt. So what will be the P? 75%. 200 into 75 by 100. So how much you get? 75% of that means calculate and post the answer. So 75% of that means how much? At what power it is operating? 75% means how much? How much, sir? 150. So it is operating at 150 megawatt. 150 megawatt. So here the fuel cost equation is given. Fuel cost equation is given in the question. How much? 0.2 P square plus 30P. 0.2 P square plus 30P plus 100. Yes or no? Plus 100. So fuel cost will be how much? 0.2 into P square is 150 square plus 30 into 150 plus 100. So how much you get? What will be the fuel cost in rupees per hour? What is the fuel cost in rupees per hour? Calculate and post the answer. Calculate it and post the answer. Okay. How much we get? Calculate and post the answer. Calculate, sir. Calculate and post the answer. How much fuel cost? How much? What is the fuel cost? What is the fuel cost? What is the fuel cost, sir? Calculate it and post the answer, sir. What do you get? 9,000. Different answer. 9,100. How much? 9,100. So 9,100 rupees per hour. What about incremental fuel cost? Incremental fuel cost is df by dp. G. Okay, that is how much? 0.4p plus 30. 0.4 into 150 plus 30. So rupees per megawatt hour. Rupees per megawatt hour. So what is the incremental fuel cost? What is the incremental fuel cost? What's the answer? What will be the incremental fuel cost? Incremental fuel cost is how much? Incremental fuel cost. How much, sir? IFC. How much do you get here? It is operating at 75, 90, yeah? Okay. 90 rupees per megawatt. Okay. So this is how you need to calculate the incremental cost and incremental fuel cost. Now we need to get the coordinate equation for economic scheduling when the transmission line losses are considered and when the transmission line losses are neglected. Okay. Before that, I'll go for this doubt session, and if you have any doubts, I will clear now, and after the break, we will solve the problems. So if you have any doubts after this, you can ask. Vinita.
Sir, in economic load dispatch, will you explain committed and non-committed once again, sir?
What do you mean by? I think you are asking about that preload dispatch, huh?
Yes, sir.
This preload dispatch. Okay.
Yes, sir.
So this is nothing but suppose you are planning for a tour, okay, to go for some 10 days tour. What you will do? You will book the vehicles, no, to meet to go for tour. So you will observe in a market. What you will observe? Good vehicle is required, and cost should be also minimum. Yes or no? Good vehicle at high cost will you book? No, cost minimum. Good vehicle you require. Here also the same. The forecasted load will be there. No, forecast in order to meet forecasted power demand. What you will do? We will commit the status of the units for tomorrow's load. Today we will plan to meet that load. That is nothing but preload dispatch. We are planning by using this preload dispatch or unit commitment. Suppose what if there are 100 generating units available. 100 generating units we will not select to meet the load. Based on the requirement, we will select. Optimally, you should select. How optimally you should select? It should meet the power demand along with certain reserve. Along with certain reserve, and the fuel cost should be also minimum. Cost of generation should be minimum. So if that unit is committed, then you will indicate there as U is equal to 1. If it is not committed, U is equal to 0. That is unit commitment. Once this is committed, then what you will do? When the tomorrow what you will do? Whatever the load that is existing, load is not constant. It is continuously varying parameter. No? On time to time basis, you need to allot the existing load. You need to allot the existing load to the committed units. How to allot? Again, the cost should be minimized. Again, the fuel cost is to be minimum. Okay.
Okay, sir.
Okay. Sushant.
Sir, hello.
Ask her.
Good evening, sir. Sir, if suddenly everything got shut down, so how
Can you
will we
speak louder?
sir, if everything got shut down, so how will we recover the power if during some kind of floods like that? How would it be?
That is an emergency condition, sir. Based on that, we will disconnect the loads and we will plan according to the existing power generation.
Sir, you mean we will gradually increase the load by
First, what you will do, you will whatever the power that has been generated as of now in that emergency condition, based on that load will be connected to that, and remaining load will be disconnected.
Okay, sir. Okay, thank you.
Shivakumar,
Sir, good evening, sir.
speak loud. Speak loud.
Good evening, sir.
Good evening.
Sir, what is the exact function of power grid, sir?
Grid is nothing but interconnection of more number of generating stations. Okay,
Okay.
that is not a single point. That is not a single point. All the generators are working together to meet the load requirement. Okay. So previously, if there are isolated generators, you cannot meet the load requirement. But if all the generators are interconnected, that is forming a grid. Okay.
Okay. Sir, ఇప్పుడు మనకు 24/7 పవర్ అవసరం ఉంటుంది కదా సార్?
Huh?
సార్ ఇప్పుడు మనకు 24/7 పవర్ అవసరం ఉంటుంది కదా?
Okay.
సో ఇప్పుడు హైడ్రల్ పవర్ స్టేషన్ లో అది పవర్ జనరేట్ కాదు, అంటే ఎప్పుడు జనరేట్ కాదు, ఓన్లీ వాటర్ ఉన్నప్పుడు జనరేట్ అవుతుంది.
Okay.
సో ఈ పవర్ ప్లాంట్ అనేది ఎట్లా డిస్ట్రిబ్యూట్ చేస్తుంది సార్ పవర్ ని?
That's what scheduling you will do, no? So you will suppose what is the amount of water that has been available at that plant. Based on that, the power that can be generated is already calculated. Okay.
Okay.
That will be committed. Once the committed means they should generate that power.
Okay.
Otherwise, they will not commit that unit.
సార్ ఇప్పుడు హైడ్రల్ పవర్ స్టేషన్ లో ఇప్పుడు ఫ్లడ్స్ ఉన్నప్పుడు వాటర్ పవర్ జనరేట్ అవుతుంది కదా, దాన్ని గ్రిడ్ కు సెండ్ చేస్తామంటారు కదా. సో వాట్ ఈస్ ద మీనింగ్ ఆఫ్ దట్ సార్?
What do you repeat your question?
ఇప్పుడు పవర్ జనరేషన్ చేసేటప్పుడు అది హైడ్రో పవర్ ప్లాంట్ లో పవర్ జనరేషన్ చేసేటప్పుడు అంటే ఫ్లడ్స్ ఉన్నప్పుడు పవర్ జనరేషన్ చేస్తారు కదా సార్.
ఫ్లడ్స్ ఉన్నప్పుడే జనరేట్ చేయాలని ఏం లేదు. అంటే దానిలో డిఫరెంట్ టైప్స్ ఆఫ్ ప్లాంట్స్ ఉంటాయి మనకి. రిజర్వాయర్ టైప్ ప్లాంట్స్, రిజర్వాయర్ టైప్ ప్లాంట్ ఫ్లడ్ లేనప్పుడు కూడా జనరేట్ చేస్తాం మనం. ఇప్పుడు శ్రీశైలం ప్లాంట్ తీసుకో, ఇప్పుడు కూడా జనరేట్ చేస్తుంది శ్రీశైలం పవర్.
రివర్స్ పంపింగ్
అనేది ఇప్పుడు కాదు, అదే that is a special case of that. But the power is, even now the power is being generated at that station. Based on the availability of water, we can decide that.
ఓకే సార్, ఇప్పుడు ఏసీ పవర్ ని మనము స్టోర్ చేసుకోలేము కదా సార్, దాన్ని ఎప్పటికప్పుడు డిస్ట్రిబ్యూట్ చేయాలి కదా.
Yes sir.
సో ఇప్పుడు మనం రిసీవ్ చేసుకుంటున్న పవర్ స్టోర్ చేసుకోకుండా వచ్చిందేనా సార్?
We are not storing the power anywhere, sir.
సార్ ఇంకోటి, ఎస్టర్డే మీరు ఒకటి చెప్పారు, ఎర్త్ స్విచ్ టాపిక్ వచ్చినప్పుడు రెసిడ్యువల్ కరెంట్ అని చెప్పారు కదా. సో ఆ కరెంట్ అనేది ఇన్ ద ఫార్మ్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్ సార్?
అదే ఏదైనా కాయిల్ లో కానీ, కెపాసిటెన్స్ లో కానీ, స్ట్రే కెపాసిటెన్స్ లో కానీ ఏదైనా ఎనర్జీ స్టోర్ అయి ఉంటే మనం వీటిని టచ్ చేసినప్పుడు అవి మన ద్వారా గ్రౌండ్ కి పాస్ అయ్యే ఛాన్సెస్ ఉంటుంది. అందుకనే అది ఎర్త్ స్విచ్ క్లోజ్ చేస్తాం.
ఓకే ఓకే సార్. సార్ టుమారో ఇస్ ద లాస్ట్ క్లాస్ నా సార్?
యా.
ఓకే సార్, ఇంకో స్మాల్ డౌట్ సార్, లాస్ట్ వన్. హలో, మనం డొమెస్టిక్ లో వాడేది 3 part టారిఫ్ 2 part టారిఫ్ సార్?
డొమెస్టిక్ లో వాడేది
3 part టారిఫ్ 2 part టారిఫ్?
డొమెస్టిక్ లో వాడేది ఓన్లీ సింగిల్ పార్ట్ టారిఫ్ వాడుతున్నాం. ఇండస్ట్రియల్ కన్స్యూమర్ కి వచ్చేది 2 part టారిఫ్.
ఓకే సార్, బ్లాక్ రేట్ టారిఫ్ అంటే ఏంటి సార్?
The tariff is again a different concept, sir. Okay. So generally, I will explain a brief overview, and you can refer that manual of the tariff.
Okay, okay.
Okay. Generally, the domestic consumers, that means our bill is done based on kilowatt hour. Suppose Y units, Y kilowatt hour, you can say it as. Okay. Suppose if you are consuming 1 unit is nothing but 1 kilowatt hour. Based on the amount of power that you have been consuming, your bill has been charged. Okay.
Okay.
And but industrial consumer on kVA also it will charge, and kilowatt hour also it will charge. Okay.
Okay sir.
This is nothing but this is fixed one per kVA.
Okay.
And this is variable.
Variable.
Running cost.
Okay. Okay.
Because kilowatt hour. There, why they are going for this means industrial load is heavy load, no? Their power factor correction. If the industries are improving their power factor, if the power factor is improved, automatically the apparent power rating goes down. So there will be
reduced.
saving in bill for the industrial consumers, but there will not be any saving in bill for domestic consumers. That's why you will not place any capacitor bank in there.
Okay, got it. Okay, sir. Thank you, sir.
Venu, ask your doubt.
Hello,
Ask your doubt, sir.
sir. You says fast synchronizing plants now, sir.
Ah,
Sir, and once you explain, sir, gas, hydel, nuclear, thermal,
that is a
you are
sequence,
arranging.
sir. That is a sequence means that is the order in which the synchronizing times. Here, the synchronizing time will be very less in case of gas plant. Okay, the synchronizing time will be very less in case of gas plant. So it is selected for peak load operation because peak load exists for only shorter duration. Okay, peak load will exist
Okay,
for only shorter duration, but thermal plant will take more time not to synchronize. That's why it is not operated as peak load plant. Okay,
okay,
this is the synchronizing
sir.
time order.
Sir, another doubt, sir. In preload dispatch, how it will reduce the fuel cost, sir?
Suppose if you have 10 generators in the market, okay,
Okay,
you will choose the generators which are healthy condition, and you should choose the generators which are having the minimum costs. So cost should be also minimum.
okay, sir. Another doubt, sir. In any example of spinning power,
Spinning
just
power means the power available at that bus bar and delivered to load. Okay.
okay,
Whatever the power, suppose here I have given no here. Suppose if you say that here this mechanical power 200 megawatt, this 200 megawatt is generating and it is delivering to load. This becomes a spinning power here.
sir. Another doubt, sir. In okay, hot power, sir. In hot
What is
power,
that?
P mechanical is not equal to 0, then
Uh,
CB is
but
opened.
but here it is not delivering any power. It is just
Sir,
floating on the bus bar like that.
sir, in excitation, sir, excitation also 0.
That is a minimum excitation and minimum inputs will be provided.
Okay, okay, sir. Okay, sir, thank you.
Vaishnavi.
Good evening, sir.
Good evening.
Sir, in impedance relay, it is non-directional relay, right, sir?
Okay.
Sir, in that we have drawn a graph like it should be operated with coordination with directional relay.
Okay.
So, in that, how did we draw that line for
You are saying that
graph?
in impedance relay, I have shown that
Yes, sir.
actually this characteristic is circle passing through a circle center at origin. Okay, whenever you coordinate a directional element like this, I have shown no.
How are we drawing that? Why
This
is
is
it?
a directional element characteristic. That is, if you plot that cos of phi minus tau on the Rx plane, you will get this.
Sorry.
Okay.
Okay. And sir, also in arc, V arc is equals to we wrote 3 to 5% of arcing voltage.
Rated voltage.
Arcing voltage in the sense
Arc
rated.
voltage is 3 to 5% of rated voltage. Rated, V rated.
Okay. Okay. Sir. Thank you, sir.
Okay. Ramachandran,
Sir, hello, sir.
ask your doubt.
If the nuclear reaction is very hard to, very difficult to control, sir, how come the load curve is so stable, sir?
How can?
Sir, how come the load curve is so stable?
I'm not getting your voice here.
Sir, the nuclear reaction is so difficult, sir. You said, sir, it's so
Can
difficult
you
to
send?
control.
Can you text me your problem? I will answer. Okay. You text me your problem. Your voice is not clear. Okay. Okay. Let us take break for 15 minutes, sir. Come back at 7 o'clock.
Hello, sir. Hello.
What is your doubt?
Sir, in subject ESC, how many marks come, sir?
I'll say that
Protection
at the
load
end.
treatment.
I'll say at the end about that all weightage always. Okay.
Okay.
Welcome back after break. Now we have seen about this fuel cost equation in case of thermal power plant. So fuel cost equation is nothing but it is an equation which shows the fuel cost variation with respect to real power generation. Here the fuel cost will be indicated in rupees per hour manner. Fuel cost curve is a curve which shows the variation of fuel cost with respect to real power generation. So there are limits. The maximum power limit is by thermal consideration, and minimum power limit is minimum power is nothing but power required to overcome the losses. And in order to minimize the fuel cost, we have differentiated that fuel cost equation with respect to real power generation. That is nothing but incremental fuel cost. So we have solved one problem based on this. Now observe. Now check whether audio and video is clear. If audio and video is clear, I request the students to just raise the hand. If audio and video is clear, I request the students to just raise the hand so that we can start our discussion. Okay. If audio and video is clear, just raise the hand, sir, so that we can start our discussion. Okay, right. Thank you. Now, practically, there will be no one. There will not be any one generator delivering the total power. No? Practically, there will be more number of generators working together to meet the load requirement. Okay. Now, let us develop the condition. That is, problem statement is like this. So what is the coordinate equation for economic scheduling when the transmission line losses are neglected? So coordinate equation for economic scheduling of thermal power plants when transmission line losses are neglected. When transmission line losses are neglected, satisfying total power generation, total real power generation is equal to power demand. So what is the coordinate equation? Now observe, this is very important, sir. Very important from exam point of view also. Very important area where the problems are asked. If you know this, understanding can be easily done. So what is asking? What is the coordinate equation for economic scheduling of thermal plants when the transmission line losses are neglected and satisfying what? Total real power generation. Total real power generation must be equal to power demand. So we need to satisfy this and we should schedule that. So how do you find the solution for this? So let us consider n generators working together. So what do you do? There will be only one, there will not be any one generator to meet the total requirement. There are many generators working together to meet the load requirement. Yes or no? So now let us consider n generators working together to meet power demand of PD. To meet the power demand of PD. Now let us consider n generators are working together to meet the power demand of what? PD. Now if you consider the n generators like this, so this is generator 1, this is generator 2, and this is the ith generator, and this is the nth generator. All these n generators are working together to meet the power demand of what? PD. Okay. Let the fuel cost of the first generator be F1, fuel cost of the second generator be F2, and fuel cost of the ith generator be Fi, and fuel cost of the nth generator be Fn. Okay. F1, F2, so on up to Fn are the fuel costs of n generators. F1, F2, so on up to Fn are what? Fuel costs of n generators. N generators. These are fuel costs of n generators. And Pg1, Pg2, Pgi, so on up to Pgn. These are the real power generations of n generators. Here Pg1, Pg2, so on up to what? Pgn are what? Real power generations. Real power generations of n generators. Okay. Now, our problem is to minimize the total fuel cost. Our problem here, problem statement is to minimize what? Total fuel cost. Okay. How do we minimize the total fuel cost? First, let us calculate what is the total fuel cost. Total fuel cost. So how do you calculate total fuel cost? Ft is equal to F1 plus F2, so on up to Fn. Yes or no? Ft is equal to F1 plus Ft, so on up to Fn. So you can mathematically write this as sigma I is equal to 1 to n Fi. We can write mathematically as sigma I is equal to 1 to n Fi. This is the total fuel cost. Our objective is to minimize this equation. Our objective is to minimize this equation 1. So fuel cost is to be minimized. Only minimizing the fuel cost is sufficient, or any condition is to be satisfied. Here the condition is total power generation must be equal to power demand. Satisfying that condition, we should minimize the total fuel cost. So what is the total power generation? Total power generation. Total power generation, how do you calculate, sir? Pgt is equal to Pg1 plus Pg2, so on up to Pgn. So how do you calculate Pgt? Pgt is equal to sigma I is equal to 1 to n Pgi. So what is the condition that must be satisfied? Condition is total power generation must be equal to power demand. Total power generation equal to power demand. That is sigma I is equal to 1 to n Pgi must be equal to what? Pd. So we need to satisfy this condition 2, and we should minimize equation 1. So we need to minimize this fuel cost, minimize the total fuel cost. Objective is to minimize the total fuel cost, that is equation 1 is to be minimized. Satisfying equation 2. So is it a constrained minimization problem or unconstrained minimization problem? Is it a constrained minimization or unconstrained minimization? Understand my point? Is it a constrained problem or unconstrained problem? It is a constrained minimization problem. So here we need to use optimization technique. So we need to minimize equation 1, that is total fuel cost. Equation 1 is total fuel cost is to be minimized. We need to minimize equation 1, that is total fuel cost, satisfying equation 2. So it is a constrained minimization problem. It is a constrained minimization problem. So it is a constrained minimization problem. So how do you convert this constrained minimization to unconstrained minimization? How can we convert this constrained minimization problem to unconstrained minimization problem? By using optimization technique. Okay. So in order to solve that, we need, so what do you need to do? We need to use optimization technique. What does it say? Optimization technique. Okay. What does this optimization technique say, sir? What does this optimization technique says? according to this optimization technique, we need to construct an auxiliary function, which says that construct an auxiliary function which includes the main function which is to be minimized, and a constraint that is to be satisfied, okay. So here we are using the optimization technique. Why you are using the optimization technique? Here we have considered n generators for optimal scheduling of plants. So total fuel cost is to be minimized. Objective is to minimize the total fuel cost. This is the total fuel cost is to be minimized. Only satisfying total fuel cost is not sufficient. We need to satisfy the condition. What is the condition? Total power generation must be equal to demand, because here losses are neglected. PL is 0. Transmission line losses are neglected. So losses are neglected. So total power generation must be equal to demand. So we need to satisfy this equation 2 and minimize this equation 1 So it is a constrained minimization or unconstrained minimization. So it is a constrained minimization problem. So as it is a constrained minimization problem, we need to use what? Optimization technique. What does this optimization technique says? Construct an auxiliary function. Here we are developing an auxiliary function which includes the main function which is to be minimized and constraint that is to be satisfied. Okay. So how do you build that? F auxiliary is equal to, what is the main function? Main function is this equation 1, that is total fuel cost is to be minimized. So that is sigma I is equal to 1 to n Fi is to be minimized, plus what is the condition that must be satisfied? Total demand minus generation must be 0. So we can also write it as what? PD minus sigma I is equal to 1 to n Pgi must be equal to 0. So we can also build like this. Okay. So demand minus generation must be equal to 0. So PD minus sigma I is equal to 1 to n Pgi. Okay. This is the condition that must be satisfied. The difference of that must be equal to 0. Okay. So now observe this auxiliary function. It includes the main function which is to be minimized and condition that must be satisfied. Yes or no? Condition that must be satisfied. So if we minimize the auxiliary function, the main function will be minimized and condition will be also satisfied. Okay. So if we minimize the auxiliary function, the main function will be minimized. And condition is satisfied. Yes or no? So we have converted the unconstrained problem to constrained problem to unconstrained problem. So how to minimize this auxiliary function? So what we got here? F auxiliary is equal to sigma I is equal to 1 to n Fi plus lambda into PD minus sigma I is equal to 1 to n Pgi. Okay. So how do you minimize this? Differentiate auxiliary function with respect to Pgi. So minimization is obtained by differentiation. So here we will apply partial differentiation. dF auxiliary by dPgi, dou Pgi. So differentiate with respect to auxiliary real power generation and equate to 0. So what you get here? D by dPgi of, first one is what? What you can say, if you expand this, what you get? Sigma I is equal to 1 to n Fi plus lambda into PD minus sigma I is equal to 1 to n Pgi is equal to 0. So now I have substituted the auxiliary function here. So how do you write here? Dou by dou Pgi of F1, F2, so on up to Fi, so on up to Fn. Okay. Plus lambda into dou PD by dou Pgi, minus dou by dou Pgi of Pg1, Pg2, so on up to Pgi, so on up to Pgn is equal to 0. Now if we observe here, we are partially differentiating. If you observe here, we are going for partial differentiation. Why you are partially differentiating? because if you observe, the fuel cost of the first generator will be influenced by the generation, real power generation of the first unit only. Okay, F1 will be influenced by PG1 only. F1 will be influenced by PG1. F2 will be influenced by PG2. Fi will be influenced by PGI. Fn will be influenced by PG1. But F1 will not influence PG2. F2 will not influence PGI. That's why we have gone for this partial differentiation. So remaining all will be turned to 0. Only this Fi term will be left over. So dou Fi by dou PGI plus lambda into, while scheduling demand is treated as constant, while scheduling PD is constant, because if you want to schedule for a load of 400 megawatt, 400 is constant. While scheduling demand is constant, PD is constant. Okay, the constant differentiation is what? 0. Constant differentiation is 0. Okay, constant differentiation is 0. Minus, here also same, dou PGI by dou PGI is the only term which is involving in that. Remaining terms are equated to 0. So dou Fi by dou PGI plus lambda into dou PG by dou PGI is what? 1. Okay, so what do you get here? Dou Fi by dou PGI minus lambda is equal to 0. So what do you get here? Dou Fi by dou PGI is equal to lambda. Dou Fi by dou PGI is equal to lambda. Okay. Now here you will substitute various values of I. Here you substitute various values of I. I is equal to 1, 2, so on up to n. What do you get here? Dou F1 by dou PG1 is equal to dou F2 by dou PG2 is equal to so on up to dou Fn by dou Pgn is equal to lambda. So this is the coordinate equation for economic scheduling of plants when the transmission line losses are neglected. So what is this, sir? This is the coordinate equation for economic operation of thermal plants when transmission line losses are neglected. When transmission line losses neglected. When transmission line losses are neglected. Sir, be patient, sir. I will explain this once again so that you will get the clear idea. So observe, what is the problem statement he has given? What is asking? What is the problem? Very important. Observe here. What is the problem statement he has given? The coordinate equation for economic operation. What is asking? The coordinate equation for economic operation of thermal plants when transmission line losses are neglected, and satisfying total real power generation must be equal to power demand. Okay, you need to satisfy that and we need to schedule. That is the question given. So for that, what do you need to do? You consider n generators working together to meet the PD demand. Okay, there are n generators working to meet this power demand of PD. This is power demand of PD. Okay, losses are neglected. PL is 0. Here F1, F2, so on up to Fn are what? Fuel costs of n generators. So what will be the total fuel cost? Add all the fuel costs of individual generators. You will get the total fuel cost. So this is the total fuel cost. Our objective is to minimize the fuel cost. If fuel cost is minimized, the cost of generation will be minimized or not? Yes or no? The cost of generation will be minimized. Okay. Only minimizing the fuel cost is sufficient, or any condition is to be satisfied? Condition is also to be satisfied. What is the condition? Total power generation must be equal to power demand. This is the total power generation, PGT, must be equal to power demand, or demand minus total generation equal to 0. This is the condition that must be satisfied. So we need to minimize this equation 1, that is total fuel cost, satisfying this equation 2. So it is what type of problem? Constrained minimization problem. So it is a what type of problem, sir? So it is a constrained minimization problem. So what do you mean by constrained minimization problem? That means two different conditions are to be satisfied. So how do you convert this constrained minimization to unconstrained minimization? We need to use optimization technique. What do you need to use? Use the optimization technique. What does the optimization technique says? Construct an auxiliary function. which includes main function which is to be minimized, and constraint that is to be satisfied, Here lambda is known as Lagrangian multiplier. Okay, Lagrangian multiplier. Okay, so we will discuss about that. So now the main function is what? The total fuel cost. This is the total fuel cost that is to be minimized, and this is the condition that must be satisfied. So we got only in one equation. So if you minimize this auxiliary function, the main function will be minimized and constraint will be satisfied. Yes or no? Okay. Now, so how do you minimize? To minimize, differentiate the auxiliary function with respect to power generation and equal to 0. df auxiliary by dpgi equal to 0. So we are applying the partial differentiation because fuel cost of first generator will influence only generation of that particular unit, but other units will not have any influence. So differentiate that and equal to 0. So you will get that condition. So what is the condition that you got? dfi by dpgi equal to lambda. So unit will be what here? Rupees per megawatt hour. So this is the incremental fuel cost. So what is your observation here? The incremental fuel cost of all the units must be same. So what is the coordinate equation that you got? The incremental fuel cost of all the units must be same, and it must be equal to Lagrangian multiplier lambda. Understood my point? What is the coordinate equation that you got? The incremental fuel cost of all the units must be same, and it must be equal to Lagrangian multiplier lambda. That is the coordinate equation for economic operation when transmission line losses are neglected. Okay. So what is the coordinate equation that you got? Coordinate equation is the incremental fuel cost. The incremental fuel cost of all the units must be same, and it must be equal to Lagrangian multiplier lambda. It will have a unit of what? Rupees per megawatt hour. So this is the coordinate equation that you need to keep in mind for economic scheduling of thermal plants when transmission line losses are neglected. When you are neglecting the transmission line loss, you need to use that equation. Okay. Now let us solve one problem so that you will get the idea about that economic operation. Okay. Just wait, sir. Let us solve this problem number 5. Observe here. Problem number 5 first. Let us observe. He has given two fuel costs. Load is how much? 130 megawatt. PD is 130 megawatt. What is the generation limits are given? P1, P2. What are the generation schedules? So try to take a screenshot of this if you are not having. Problem number 5. I will try to solve that. Then we can go. Problem number 5. Okay. Now let us go. I will solve this. So how to solve the problem given? So problem number 5, CRO, classroom objectives. Okay. What is the fuel cost equation given? F1 is equal to 0.2 P1 square plus 30 P1 plus 100. F1 is equal to 0.2 P1 square plus 30 P1 plus 100 rupees per hour. This is the first equation that is given. And F2 is 0.25 P2 square plus 40 P2 plus 100. F2 is equal to 0.25 P2 square, 0.25 P2 square plus 40 P2 plus 40 P2 plus 40 P2 plus 150 rupees per hour. 150 rupees per hour. Okay. And what he has given load, how much? 130 megawatt. Load is 130 megawatt. So this is the given data. And what are the limits given? P1 is 20 and 80. 20 less than or equal to P1 less than or equal to 80 that are given. P2 limits are 40 less than or equal to P2 less than or equal to 100. 40 less than or equal to P2 less than or equal to 100. This is megawatt. This is the question given. And what are the generation schedules? What are the generation schedules? So how do you calculate? What is the coordinate equation that you got? The incremental fuel cost of all the units must be same. Here, how many units are there? 2 units are there. So what is the coordinate equation? How do you find the solution for this? He's asking to calculate what is P1 value and what is P2 value. How do you find? So what is the coordinate equation? df1 by dp1 must be equal to what? df2 by dp2. Yes or no? df1 by dp1 must be equal to df2 by dp2. That is the coordinate equation that you got. The incremental fuel cost of all the units must be same. Yes or no? This is nothing but incremental fuel cost of first unit. This is the incremental fuel cost of second unit. So if you differentiate, what do you get here? 0.4 P1 plus 30 must be equal to 0.5 P2 plus 40. Okay. So one equation you got, that is 0.4 P1 minus 0.5 P2 is equal to what? 10. You got one equation, yes or no? So we got one equation, that is from the coordinate equation. So how many unknowns are there? Here you need to calculate what? P1 and P2. Here you should calculate P1 and P2. So we got only one equation. How the second equation is developed? PD is equal to how much? 130. So P1 plus P2 must be equal to 130. Yes or no? PD must be equal to total power generation. That is the condition, no? So here the second equation. Two unknowns, you got two equations. That is 0.4 P1 minus, so 0.4 P1 minus 0.5 P2 minus 0.5 P2 is equal to 10. That is one equation. And the other equation is what? P1 plus P2 is 130. P1 plus P2 is 130. So solve these equations. You'll get P1 and P2. So anyone try to solve this and post the answer? What is the value of P1 and P2? Anyone solve and post the answer, sir? Anyone solve and post the answer? Post the values of P1 and P2. Try to solve and post the answer. P1 is 83.33, P2 is 46. P1 is 83.33 megawatt. P2 is how much? 46.67 megawatt. 46.67 megawatt. Okay. I think all of you got the same. Right. Now observe here. So what is asking to calculate P1 and P2? So what are the limits on P1? Observe the limits on P1. 20 less than or equal to P1 less than or equal to 80. But P1 what you got here? 83. P1 what you got? 83 you got. But the limits on P1 is what? 20 less than or equal to P1 less than or equal to 80 megawatt should be there. That means P1 is violating what? Maximum limit. Understand my point here? P1 is violating the maximum limit here. P1 is violating the maximum limit. Yes or no? P1 is violating maximum limit. What do you need to do? We should not generate more than its maximum limit. Yes or no? I have already said, due to thermal consideration, it is violating the maximum limit. So P1 is greater than what? P max. Yes or no? P1 is greater than P max. So what you need to do? Set P1 is equal to P maximum. What do you need to do? Set P1 is equal to P1 maximum. P1 maximum. What is P1 maximum? P1 maximum is 80. So P1 should be set to what? 80 megawatt. P1 should be set to 80 megawatt. And what about P2 then? How do you calculate? P1 plus P2 should be equal to how much? 130. So P1 is 80 plus P2 is equal to 130. So what is the value of P2 that you will get? 130 minus 80. So 50 megawatt. 50 megawatt. So now what is the generation schedule? What is the solution? P1 is 80 megawatt. P2 is 50 megawatt. P1 is 80 megawatt. P2 is 50 megawatt. So what is your conclusion? Whenever the limits are violated, whenever the limits are violated, what do you need to do? So suppose P is greater than P minimum, sorry, suppose P is less than P minimum, what do you need to do? Set P is equal to P minimum. Okay, set P is equal to P minimum. If P is greater than P maximum, what do you need to do? Then we need to set P is equal to P maximum. So whichever the limit that has been violated, you need to set it to its value. Okay. Now in this question, what he has given, observe. I will repeat this once again. You observe, he has given the fuel cost equations. Fuel cost equations given in rupees per hour. PD, power demand is how much? 130 megawatt, and limits are given. Limits are given on generations. So what is the coordinate equation? This is the coordinate equation. Coordinate equation is what? The incremental fuel cost of all the units must be same. The incremental fuel cost of all the units must be same. That means df by dp1 must be equal to df2 by dp2. That's what equation you got, no? df1 by dpg1, df2 by dpg2. All the units must be having the same incremental fuel cost, sir. That's what you have done here. The incremental, equate those two incremental fuel costs, differentiate with respect to P1, you'll get df1 by dp1. So here you can write it as dou f1 by dou p1 is what? 0.4 p1 plus 30. And what about this here? Dou f2 by dou p2. If you differentiate, what do you get? 0.5 p2 plus 40 you're getting. Okay. So if you equate, you will get one equation. But there are two unknowns here. How many unknowns are there? Two unknowns. You require two equations. So how do you develop the second equation? Total power generation. Total power generation. P1 plus P2 must be equal to PD. P1 plus P2 equal to PD. Okay. Now if you solve these two, you will get P1 and P2. But here P1 is violating the maximum limit. P1 is violating the maximum limit. So what you need to do? Set P1 to P max and calculate P2. So P2 remaining power is to be allotted to P2. So this is the answer or solution. Solution is what? P1 is 80 megawatt, P2 is 50 megawatt. So whenever the limits are violated, we need to set to that respective limits. Got my point? So if it is violating maximum limit, you should set to maximum limit. If it is violating minimum limit, you need to set to minimum limit. Okay. Now I'll go for that questionnaire once again and observe. So problem number 5. So problem number 5, what is the solution that has been given? Observe here, problem number 5. What is the answer given? P1 is 80 megawatt, P2 is 50 megawatt. P1 is 80 megawatt, P2 is 50 megawatt. Understood? Is it clear? Okay. So that is a procedure to solve that. Now, here you have completed this fifth problem. Okay. Now try to solve this problem number 3. Problem number 3. What he has given? Problem number 3. The cost curves of 2 units. Cost curves of 2 units given. And the generation limits are given 100 less than or equal to 650, 50 less than or equal to 500. Load is how much? 600 here. PD is how much? 600 megawatt given. Now try to solve this problem number 3. Take the screenshot of this. Take the screenshot of this. Problem number 3. Try to solve. Problem number 3. Try to solve that. So power system has 2 generators with the following cost curve. So C of Pg1 is this one, C of Pg2 is this one. So what do you get? So I'm moving to that our slide. I think all of you got the screenshot of this. Problem number 6. So CRO. Problem number 6. What he has given? Given the cost curve, so not problem number 6, it is problem number 3, sir. Problem number 3. So problem number 3, what he has given? C of Pg1 is C of Pg1. The cost curves given C of Pg1 and C of Pg2 values are given. C of Pg1 and C of Pg1 and C of Pg2 values are given here. So C of Pg1 is what? 0.006 Pg1 square, 0.006 Pg1 square plus 8 Pg1 plus 350. 8 Pg1 plus 350. What about Pg2? What about Pg2? 0.009 Pg2 square, 0.009 Pg2 square plus 7 Pg2 plus 400 plus 400. So these are the cost curves given, rupees per hour. These are the cost curves given, and limits are given on Pg1 100 and 650. 100 less than or equal to Pg1 less than or equal to 650, and limits are given on Pg2 50 and 500. 50 less than or equal to Pg2 less than or equal to 500, and PD 600 megawatt. PD is 600. PD is 600. Sorry, not 60. PD is 600 megawatt. PD is how much here? 600 megawatt. Okay. Now, how do you solve this problem? How do you solve this problem? What is asking? What is asking? What is Pg1 and Pg2? Here losses are neglected. Losses are neglected. How do you solve, sir? Here also, instead of f, here you can also write f of Pg1 and f of Pg2. Meaning is same, sir. Cost or fuel cost, both are same. So how do you find the solution? df1 by dpg1 must be equal to what? df2 by dpg2. That is, the coordinate equation for both the units must be same, yes or no? So if you differentiate, what do you get here? 0.012 pg1 plus 8 is equal to 0.018 pg2 plus 7 plus 7. Okay. 0.012 pg1 minus 0.018 pg2 is equal to what? Take this on the other side, you'll get this minus 1. This is the first equation. So how do you develop the first equation? By using the coordinate equation, yes or no? Differentiate that. Differentiate this first equation, you'll get df1 by dpg1. df1 by dpg1, differentiate, what do you get? 0.012 pg1 plus 8, and if you differentiate this, you will get df2 by dpg2. What do you get here? 0.018 pg2 plus 7. Okay, so you got this one. What about the second equation? How do you get? Here PD is how much? 600, and pg1 plus pg2 is 600. pg1 plus pg2 is 600. So this is the second equation. This is the second equation. So if you can solve this 1 and 2, you will get pg1 and pg2. If you can solve this equation 1 and 2, you will get pg1 and pg2. So what is the first equation? 0.012 pg1, 0.012 pg1 minus 0.018 pg2 is equal to minus 1, and pg1 plus pg2 is 600, and pg1 plus pg2 is 600. So solve this, you will get pg1 and pg2. Solve these two equations, you will get the values of pg1 and pg2. Anyone solve this and post the answers, sir? Solve these equations and post the answer. Solve pg1 and pg2. Solve for pg1 and pg2 and post the answer. 326.67, 326.67 and 67 megawatt and 273.33 megawatt. Okay, so this is the answer. Now observe the limits, whether they are within the limits or not. First one is 100 and 650. pg1 is to be between 100 and 650. So first one is within the limit, no problem. Second one is 50 to 500 within the limits. So answer is this one, PG1 and PG2 are within the limits, so no need to change. So if they are within the limits, don't disturb. If they are violating the limits only, then set the values. Okay. If they are within the limits, answer is within limits. Within limits. So PG1 is how much here? PG1 is 326.67 megawatt, and the PG2 is 273.33 megawatt. Okay. No need to disturb these values. Got the point? How to solve? Got it or not? How to calculate? Okay. So in this problem, what he has given, the fuel cost, CRPF, both are same, sir. Indication of with the C of PG1 or F of PG1, both are same. Then first you calculate the incremental fuel cost, dF1 by dPg1 and dF2 by dPg2. Equate those two, you will get the this is according to coordinate equation, yes or no? This is according to our coordinate equation that we have solved. Okay. So dF1 by dPg1 is equal to dF2 by dPg2. Based on that, you will get this values. And the second equation, how do we calculate? PD is 600 megawatt that we got. So PG1 plus PG2 is equal to 600. So solve those two equations, you will get PG1 and PG2. I think all of you have understood this one or not? I think all of you got this, how to calculate. Understood? So now let us go for the problem. Problem number 3, let us verify the answers. Problem number 3. So here observe problem number 3. This is the P1 and this is P2. Okay. It's P1 and P2. Understood my point? Okay. Now let us go for this the second problem, sir. Now let us go for this second problem. Observe what he has given. The following three incremental cost curves are given: PG1, PG2, PG3 given. PG1, PG2, PG3 values in terms of incremental cost given. Okay. And IC is the incremental cost in rupees per megawatt hour. And total load is how much? 500. PD is 500 megawatt. What is asking? Neglecting transmission line losses, find the optimal generation schedule. Neglect the transmission line loss and find the optimal generation schedule for this. Okay. So take the screenshot of this second bit. Let's try to solve. So how do you solve this? So how do you solve the second one, sir? Observe here. Now going for the second problem, CRO, problem number 2. Okay. Problem number 2. Now what he has given, PG1 is minus 120 plus 60 IC1 minus 2.5 IC1 square. PG1 is minus 120 plus 60 IC1 plus 60 IC1 minus 2.5 IC1 square minus 2.5 IC1 square, and PG2 is minus 140. PG2 is minus 140. PG2 is minus 140 plus 40 IC2 plus 40 IC2 minus 2 IC2 square minus 2 IC2 square. What about PG3 that you will get? PG3 is minus 90 plus 50 IC3 minus 90 plus 50 IC3 minus 1.5 IC3 square minus 1.5 IC3 square. This is given in the question. Okay, this is given in the question. So here load kitna load 500 megawatt. PD given as 500 megawatt. What is asking to calculate here? Is asking to calculate what is the value of PG1, PG2 and PG3. What is the generation schedule he is asking to calculate. So how do you calculate? How can we find the solution for this problem? How can we find the solution for this problem? So what is the coordinate equation? Here there are 3 units. Here there are how many units, sir? 3 units. There are 3 units. So how do you find the solution? df1 by dpg1 must be equal to df2 by dpg2 must be equal to df3 by dpg3 is equal to lambda. So this condition must be satisfied. Or you can also say IC1 is equal to IC2 is equal to IC3 is equal to lambda. Okay, you can satisfy this condition. So let it be equation 1. Let it be equation 1. Okay. And what is the second condition that can be satisfied? PD is equal to 500. So what do you get here? PG1 plus PG2 plus PG3 is equal to 500. PG1 plus PG2 plus PG3 is equal to 500. Now here substitute IC1, IC2, IC3 equal to lambda. So what is the value of PG1 that you get? Minus 120 plus 60 lambda minus 2.5 lambda square. Okay, this is PG1. Okay. What is PG2? Minus 140 plus 40 lambda minus 2 lambda square. What is PG3? Minus 90 plus 50 lambda minus 1.5 lambda square is equal to 0. Now add this all the values, you will get in the form of a quadratic equation. So if you add all these values, you will get in the form of a quadratic equation. So what does that equation will have? That equation, if you simplify, that equation will be in terms of what? Lambda square, lambda and constant. So if you simplify this equation, how do you get? So that equation, if you simplify, you will get it as 6 lambda square minus 150 lambda plus 850 is equal to 0. Okay, that is the equation. So if you, this is a quadratic equation. Lambda value will be what? Minus b plus or minus square root of b square minus 4ac by 2a. This is the second order equation, yes or no? Here, so you will get the lambda values. Lambda, two values you will be getting. Lambda 1 and the lambda 2. Here you will be getting. One value will be 16.31 rupees per megawatt hour. And the other value will be 8.68 rupees per megawatt hour. 8.68 rupees per megawatt hour. Now, which one is to be selected here? Now, which one is to be selected? Whether you should select lambda 1 or lambda 2. Whether you should select lambda 1 or lambda 2. Don't confuse her. Here, what he has given? Here, power generation in terms of incremental cost given. IC is what? Incremental fuel cost. Okay. PG is in terms of incremental cost given. 3 units are given. Demand is 500 given. Demand is, sorry, here not 0. It is 500. I have wrongly written. Here it is 500. Now, demand is 500 given. So, PG1 plus PG2 plus PG3 is equal to 500. So, if you simplify this, you will get a second order equation. Here, the coordinate equation is what? The incremental fuel cost of all the units must be same. df1 by dpg1 equal to df2 by dpg2 equal to df3 by dpg3 equal to lambda. That means IC1, IC2, IC3. This is what? IC1, this is IC2 and this is IC3 must be equal to lambda. Okay. So now instead of IC1 you can substitute it as lambda. IC2 also lambda, IC3 also lambda. So you got the second order equation or quadratic equation. Solve this. So which lambda is to be selected here? Our cost should be minimum. So for optimal value is what? 8.68. So you should not consider this value. You should not consider this lambda 1 is to be neglected. Because more value, no, it will be rupees per megawatt hour is more means it will give more cost. So you should select here lambda value as what? 8.68 rupees per megawatt hour. Because the cost is minimum. Cost to be minimum. Okay. Now IC1 is equal to IC2 is equal to IC3 is equal to lambda, that is 8.68 value. 8.68 rupees per megawatt hour. 8.68 rupees per megawatt hour. Now you know IC1, IC2, IC3. Can you calculate PG1, PG2, PG3 or not? Yes or no? So can you calculate PG1? So PG1 value, how do you calculate here? Substitute. PG1 is, what you got here, minus 120, minus 120 plus 60 into IC1, 8.68, 8.68 minus 2.5 square minus, minus 2.5 into 8.68 square. So if you simplify this, you will get the value of PG1. PG1, how much we get, sir? 212.44 megawatt you are getting. Okay. PG2, substitute here IC2. IC2, IC1, IC3, same one. Minus 140, minus 140 plus 40 into IC2. 40 into IC2 is 8.68 minus 2 IC2 square. 2 into 8.68 square. So if you simplify this, you will get the value of PG2. PG2 56.51. Okay, 56.51 megawatt. What about PG3? PG3 also same. PG3 is equal to what you got? Minus 90 plus 50 into IC3 is 8.68 minus 1.5 minus 1.5 IC3 square. IC3 square is 8.68 square. So if you simplify, you will get the value of PG3. PG3 is 230.98 megawatt. 230.98. So here he is asking to calculate PG1, PG2 and PG3. PG1, PG2 and PG3. So the solution is simple. So first you need to develop the equation, that is PG1 plus PG2 plus PG3 equal to PD, that is 500 megawatt, given in the question only. Okay. Now IC1, IC2, IC3 are equal. So here you should not confuse which lambda is to be selected. The cost should be minimum or maximum. The cost should be minimum. So minimum lambda you select here. So 8.68 and substitute, you will get the values of PG1, PG2 and PG3. Understood? I think you got the idea how to select this. Okay. So now let us go for the question page, second one, whether we got the same or not. Let us cross check. Second question. Observe here, P1 212.46, P2 is 56.51, P3 is 231.0. Approximately nearly same. Now let us go for another question. Observe here, problem number 6. Problem number 6, observe. Load of 300 megawatt. That means PD is how much here? PD is 300 megawatt. Load of 300 megawatt is supplied by two alternators. Load of 300 megawatt is supplied by two alternators having the capacities 200 megawatt each. Incremental costs are given, dF1 by dP1, dF2 by dP2 given. The most economical division of load between two generators. What is asking? Here there are two questions. First question is the most economical division of load between two generators. And the second question is saving in rupees, that is fuel cost per annum, when the load is shared equally between the alternators. So compare economic sharing with equal sharing, and what is the saving in cost he is asked to calculate. Now take the screenshot of this problem number 6. Let us try to solve this problem number 6. Problem number 6. Identify this problem number 6. Load given as 300 megawatt, dF1 by dP1, dF2 by dP2 directly given. Okay. Now I am going to share it. Problem number 6. Okay. CRO. Problem number 6. What he has given? dF1 by dP1 is 0.1 P1 plus 20. dF1 by dP1 is 0.1 P1 plus 20. Okay. dF2 by dP2 is 0.1 P2 plus 15. dF2 by dP2 is 0.1 P2 plus 15. So no, 15 rupees per megawatt hour. Rupees per megawatt hour. Rupees per megawatt hour. What is saying? Load is how much? 300 megawatt. PD is 300 megawatt. PD is 300 megawatt. Now find the optimal scheduling here. P1 is how much? P2 is how much? Optimal scheduling. Okay. Optimal scheduling. So how do you find the optimal scheduling? How do you find the solution for this? How do you find the solution, sir? What is the coordinate equation? What is the coordinate equation for economic operation? What is the coordinate equation for economic operation? What is the coordinate equation, sir? Incremental cost must be same, yes or no? df1 by, just wait. Yes, wait, sir, it has been said. Okay. Here df1 by dp1 must be equal to what? df1 by dp1 must be equal to df2 by dp2, yes or no? So this is 0.1 p1 plus 20 is equal to 0.1 p2 plus 15. Okay. So if you simplify, what do you get? 0.1 p1 minus 0.1 p2 is equal to minus 5. So you got one equation, yes or no? You got one equation. And what is the second equation that you got? PD is 300. PD is given as 300 megawatt. So P1 plus P2 must be how much? 300 megawatt. 300 megawatt of 300 watt. Don't consider. So this is the second equation. Now if you solve this equation 1 and 2, you will get P1 and P2. So 0.1 P1 minus 0.2 P2 is equal to what? 0.1 P1 minus 0.2 P2 is equal to minus 5. And P1 plus P2 is how much? P1 plus P2 is how much here? 300. 300. Now solve these two. Solve these two. You will get P1 and P2. Solve these two. You will get the values of P1 and P2. Solve these two, sir, and post the answer. What is the value of P1 and P2? Solve and post the answer. 125, 175. Okay. 125 megawatt and 175 megawatt. 175 megawatt. So this is the problem. Now observe what he is asking. I am 125 megawatt and 175 megawatt. Again I am sharing that question. Observe first question, what is asking? The most economical division of load between the two generators. That has completed. And the second question you observe here. And second question, if you observe here, second question what is asking? Saving in rupees in fuel cost when load is shared equally between the alternators. So what is the fuel cost? When economic operation and equal loading of share you need to compute. Economic operation and equal loading of share you need to compute, and observe what is the saving. What is the saving in rupees that you need to identify. Okay. So how do you formulate that? So now observe this problem here. The fuel cost equation is what? Half alpha Pg square plus beta Pg plus gamma. Okay. And incremental fuel cost dF by dPg is what? Alpha Pg plus beta. Alpha Pg plus beta. Okay. Yes or no? So here we know the incremental fuel cost. Here we know the incremental fuel cost. But fuel cost is to be formulated. Fuel cost is to be formulated from this. So how do you formulate the fuel cost equation from that? So we know df1 by dp1, df1 by dp1. Leave it here. df1 by dp1 is how much? 0.1 p1 plus 20. 0.1 p1, 0.1 p1 plus 20 you got. So here what do you get? 0.1 by 2, 0.1 by 2 into P1 square plus 20 P1 plus some constant K1. Okay, this is dF1. This is the fuel cost of the first unit. This is the fuel cost of the first unit. What is dF2 by dP2? 0.1 P2 plus 15. dF2 by dP2 is 0.1 P2 plus 15. 0.1 P2 plus 15. So F2 will be what? 0.1 P2 square by 2 plus 15 P2 plus K2. This is the fuel cost of the second unit. Yes or no? This is the fuel cost of the second unit you got. Now you need to calculate for economic division as well as equal division. First, let us go for economic operation. Economic operation cost. Operation cost. So what is the F1? F1 that you got 0.1 by 2 P1 square, 0.1 by 2 P1 square plus 20 P1 plus K1 plus 20 P1 plus K1. So that is 0.1 by 2. P1 is what? P1 is 125. 125 square plus 20 into 125 plus K1 you will get. Plus K1 you will get. And F2 is what? 0.1 by 2 P2 square. 0.1 by 2 P2 square plus 15 P2 plus 15 P2 plus K2. Okay. 0.1 by 2 P2 square. P2 how much you got here? 175. P2 is 175. 175 square plus 15 into 175 plus K2. Okay. Understood my point? Now what is the total fuel cost here? So FT1, add F1 plus F2. If you add this, what do you get? Here 0.1 by 2 is common. 0.1 by 2 is common. What do you get here? 125 square plus 175 square plus 20 into 125 plus 15 into 175 plus K1 plus K2. So this is the fuel cost equation. When, sir? When this is the fuel cost when economic operation, for economic operation. Okay. So just wait. So when economic operation, you will get this fuel cost. For economic operation, you got this fuel cost. Okay. So now, what is the total fuel cost that you will get if you simplify this FT1? That is, you simplify, what do you get here? Simplify and equal division. What do you get here? Equal division. FT2 equal division. Equal division means equal division. P1 is equal to P2 is equal to how much here? Equal division means P1 is equal to P2 is equal to 150 megawatt because 300 load. So F1 plus F2. So what do you get here? 0.1 by 2, 150 square plus 150 square plus 20 into 150 plus 15 into 150 plus K1 plus K2. K1 plus K2. Now, what is the saving in cost? He is asking to calculate the saving. Saving in cost, how do you calculate? FT2 minus FT1. FT2 minus FT1. So, if you find the difference of this, you will be getting the saving in cost. That is, you will get 9.1 rupees per hour. 9.1 rupees per hour. But he is asking per annum, he is asking. Per annum, he is asking. So, saving in rupees per annum, 9.1 into per hour. In a day, you will get 24 hours. In a year, you will get 365 days. So, rupees per annum saving will be how much? 79716 rupees per annum. So, this is the saving in rupees per annum. This is the saving in rupees per annum. So, when you consider this equal division and economic division, when you consider the equal division and economic division, okay. Observe this carefully. What he has given, sixth problem. So the fuel cost, incremental fuel cost, these are incremental fuel costs given, and power demand is given as 300 megawatt. What is the optimal scheduling is asked? This is the first bit, A bit. So you got the coordinate equation, you will get one equation. Power demand is 300 megawatt, that is given. So P1 plus P2 is equal to 300. From that you will get the second equation. And you solve that, you will get P1 and P2. So that are within the limit, so no problem. But what is the saving in cost is asking. So you know that this is a fuel cost equation and this is the incremental fuel cost equation. So from this incremental fuel cost, you should develop the fuel cost equations. Okay? From the incremental fuel cost equation, you should develop the fuel cost equation and solve here and solve here. You substitute for economic operation, you got P1 and P2. And the equal division of load P1 and P2 is equal to 500. For equal division of load P1 equal to P2 equal to 150, sir. So if you substitute that, you will get the saving in rupees per annum. So actually you will get 9.1 rupees per hour. You will get 9.1 rupees per hour. You will get. But per annum he is asking to calculate. So 7 multiply with 24 and 365. 24 hours in a day, 365 hours. So 365 days in an year. So that is how you need to solve. Now let us go for the question again. So here there is a saving in cost. That's what he is asking to calculate. This is the 60th problem. Now I request the students to solve this problem number 1 first bit. Problem number 1 first bit. Observe this problem number 1. So incremental fuel costs of the two units are given. Incremental fuel costs of the two units are given. 0.1 P1 plus 20 and the other one is 0.12 P2 plus 16. So limits are given 20 less than or equal to P less than or equal to 150. Sorry, 125. Calculate if PD is 40, calculate P1, P2 and lambda. So how to solve this? Take the screenshot of this first question and try to solve. Just wait. So take the screenshot of this first question and try to solve this first bit. Okay. So try to solve this first bit, sir. So df1 by dp1 given, df2 by dp2 given. First bit PD is how much? 40. If PD is 40, calculate P1, P2 and lambda. That's what he's asking to calculate. Okay. Now I am trying to go for our workbook. So question number 1, CRO. CRO, question number 1. He has given df1 by dp1 and a df2 by dp2. df2 by dp2. So what is df1 by dp1 given? 0.1 p1 plus 20. 0.1 p1 plus 20 gram. And df2 by dp2 is 0.12 p2 plus 16. 0.12 p2 plus 16. These values are given. And limits are given as what? 20 less than or equal to p less than or equal to 125. 20 less than or equal to p less than or equal to 125. So in this first bit, A bit, what he has given? PD is 40. Calculate if PD is 40 megawatt. What is P1 value, P2 value, and a lambda value he is asking to calculate. Okay. So try to solve this. So how do you solve, sir? How do you find the solution for this? So what is the coordinate equation? df1 by dp1 must be equal to what? df2 by dp2. So from this, what do you get here? 0.1 p1, 0.1 p1 plus 20 is equal to 0.12 p2 plus 16. Yes or no? So 0.1 p1 minus 0.12 p2 is equal to minus 4. You got one equation. So you got one equation from what? Coordinate equation. So you got one equation from coordinate equation you got. Okay. And how do you develop the second equation? Here PD is given as what? 40. So from this what you get? P1 plus P2 is equal to 40. P1 plus P2 is equal to 40. This is the second equation. Solve 1 and 2, you will get P1 and P2. So what you got here? 0.1 P1 minus 0.12 P2 minus 0.12 P2 is equal to minus 4. P1 plus P2 equal to 40. P1 plus P2 is equal to 40. So solve these two, you will get the values of P1 and P2. Solve these two, you will get the values of P1 and P2 in megawatt. So anyone solve and post the answers, sir? Solve and post the answers of P1 and P2. Solve and post the answer for P1 and P2. Solve and post the answer. So solve correctly. So you got you will get P1 value as 3.63 megawatt and this is 36.36 megawatt. So these are the values that you get. Okay. Now observe what are the limits that are given in the question. What are the limits that are given in the question? 20 less than or equal to P less than or equal to 125. So, but 20 less than or equal to P less than or equal to 125 megawatt. These are the limits. But observe which one is violating. P1 is violating the minimum limit or not here. P1 is violating minimum limit or not. Yes or no? P1 is violating the minimum limit. Here P1 is violating minimum limit. Minimum limit. So P1 is less than P minimum. So whenever it is violating minimum limit, what you need to set? P1 is equal to P minimum. Okay, set P1 is equal to P minimum. So P minimum is how much? 20 megawatt. So P1 plus P2 is equal to 40. So P1 is 20 plus P2 is equal to 40. So you will get P2 is also how much? 20 megawatt. So you got P1 as 20 megawatt and P2 also as 20 megawatt. So I think you got the solution here. So you got P1 is 20 megawatt and P2 is also how much? 20 megawatt. But what about lambda? Is also asking to calculate the lambda in the question. Is also asking to calculate the lambda. So how do you calculate lambda? Here you will get lambda 1, that is df1 by dp1. You will get this is lambda 1, and lambda 2 is df2 by dp2. df2 by dp2. df1 by dp1 is how much here given? 0.1 p1 plus 20. 0.1 into p1 plus 20. So that is nothing but 0.1 into p1 is 20 plus 20. Okay. How much do you get? This is 22 rupees per megawatt hour. 22 rupees per megawatt hour. What about lambda 2 df2 by dp2? 0.12 p2 plus 16. 0.12 p2 plus 16. That is 0.12 into p2 is how much here? P2 is also 20 plus 16. So how much do you get? How much do you get here? This one, if you simplify, how much do you get? Post the answer. Lambda 2, how much do you get? Lambda 2 value, how much do you get? 18.4. 18.4 rupees per megawatt hour. 18.4 rupees per megawatt hour. But which value is to be selected? Whether you should select lambda 1 or lambda 2. Whether you should select, this is very important, sir. Listen here. Which value is to be selected here? Whether you should select lambda 1 or lambda 2. Here lambda value is decided by the unit which is participating in the economic dispatch program. Lambda value is decided by what? The unit which is participating in economic dispatch program. Observe here, P1 is violating the limit. P1 is violating the limit. So you should not consider lambda 1. So you should not consider lambda 1. So lambda 1 you got how much? Lambda 1 that is 22 rupees per megawatt hour. And lambda 2 is 18.4 rupees per megawatt hour. 18.4 rupees per megawatt hour. So which value is to be selected? Lambda value is decided by unit participating in economic dispatch program. Okay. So lambda value is decided by the unit which is participating in economic dispatch program. So which is participating in economic dispatch program, P1 or P2? P1 is violating the limit. So you should not select lambda 1. P1 is violating the limit. P1 is violated limit. So you should not select lambda 1. So lambda value is how much? 18.4 rupees per megawatt hour. So here how the lambda value is to be decided? Lambda value is to be decided by the unit which is participating in economic dispatch program. I will explain this question once again if you observe. First question, what is given? df1 by dp1 is 0.1 p1 plus 20. df2 by dp2 is given as 0.12 p2 plus 16. Limits are given 20 less than or equal to p less than or equal to 125 megawatt. PD given as how much? 40 megawatt. PD given as 40 megawatt. P1, P2 lambda values he is asking to calculate. So how do you calculate here? How do you calculate? Use the coordinate equation. Use the coordinate equation. What is the coordinate equation? incremental fuel cost of all the units must be same. dF1 by dP1 must be equal to what? dF2 by dP2. So if you get this, you'll get this question. PD is how much? 40. So P1 plus P2 40. Solve these two, you'll get P1 and P2. You got the P1 value, but P1 is violating what? Minimum limit. Minimum limit is 20. So set P1 is equal to P minimum 20 you will get, and P2 you solve by this balance equation. So you got P1 and P2 as 20 megawatt. But lambda values will get two different lambda values. Which lambda value is to be selected? Lambda value is decided by the unit which is participating in economic dispatch programs. Lambda value is decided by the unit which is participating in economic dispatch program. Understood my point? Is it clear? Lambda value is decided by the unit which is participating in economic dispatch program. Okay. Now I will try to solve this problem number 2, sir. Now this second PD is 250 megawatt. Calculate P1, P2 and lambda. PD is 250 megawatt. PD is 250 megawatt. Calculate P1, P2 and lambda. PD is 250 megawatt. Calculate P1, P2 and lambda. So now the second bit I'm trying to solve. So in second bit, what is asking? B bit. PD is 250 megawatt. Calculate P1, P2 and lambda. So how do you solve this problem? dF1 by dP1 must be equal to what? dF2 by dP2. dF1 by dP1 equal to dF2 by dP2. Here dF1 by dP1 given as what? 0.1 P1 plus 20. 0.1 P1 plus 20. 0.1 P1 plus 20. What about dF2 by dP2? 0.12 P2 plus 16. 0.12 P2 plus 16. Here 0.1 P1 minus 0.12 P2 is equal to minus 4. This is equation number 1. Okay. What about second equation that you got? PD is 250 megawatt. So P1 plus P2 is equal to 250. Okay. P1 plus P2 equal to 250. So you got the second equation. Now solve these two equations. So 0.1 P1 minus 0.12 P2 is equal to minus 4. P1 plus P2 is equal to 250. Now solve these two equations. You will get the values of P1 and P2. Solve these two equations and post the answers for P1 and P2, sir. Post the answers for P1 and P2. So what you got? P1 as 118.18 megawatt. P2 is 131.81 megawatt. 131.81 megawatt. Now observe what are the limits that are given in the question. Limits that are given in the question are 20 less than or equal to P less than or equal to 125. Two limits are what? 20 less than or equal to P less than or equal to 125 megawatt. So which one is violating the limit here? Observe here which one is violating the limit. P2 is violating the limit. P2 is violating which limit? Maximum limit or minimum limit? P2 is violating the maximum limit. Okay. Now generator 2 is violating maximum limit. So P2 is greater than P maximum. P2 is greater than P maximum. P maximum is 125. So P2 should be set to P maximum. The P2 is 125. Set P2 to P maximum 125 megawatt. P2 is 125 megawatt. Okay. Now what about P1? Here P1 plus P2 is equal to how much? 250. No, 250. So P1 plus 125 is equal to 250. So P1 is equal to 125 megawatt. P1 is equal to 125 megawatt. So you got P1 is equal to 125 megawatt. P2 is also equal to what? 125 megawatt. So what about lambda 1? dF1 by dP1. What about lambda 2? dF2 by dP2. So how do you calculate dF1 by dP1? 0.1 P1 plus 20. 0.1 P1 plus 20. That is 0.1 into 125 plus 20. Calculate lambda 1. How much you get? And dF2 by dP2 how much? 0.12 P2 plus 16. 0.12 P2 plus 16. So 0.12 into P2 is how much here? 125 plus 16. So calculate lambda 1 and lambda 2 and post the answers. Calculate lambda 1 and lambda 2 and post the answers. Calculate lambda 1 and lambda 2 and post the answers. Lambda 1, lambda 2. 32.5, 31. So 32.5 rupees per megawatt hour and 31 rupees per megawatt hour. So which value of lambda is to be selected here? Lambda value is decided by the unit which is participating in economic dispatch program. Lambda value is decided by the unit which is participating in economic dispatch program. So if you observe, P2 is violating the limit. So lambda, here lambda 1 you got that is 32.5 rupees per megawatt hour. Lambda 2 is 31 rupees per megawatt hour. Lambda 2 is 31 rupees per megawatt hour. So which lambda is to be selected? You should not, sorry, P2 is violating the maximum limit. So, sorry, P2 is violating what? Maximum limit. So you should not select this, lambda 2. So what value? Lambda 1 is to be selected. So lambda value is how much? 32.5 rupees per megawatt hour. Because P2 is violating the limit. So lambda value is decided by the unit which is participated in economic dispatch program. Which is participating? Unit 1 is participating in the economic dispatch program. I think you got this. So in the second question, what is asked? So 250, what is P1, P2 and lambda? So first coordinate equation you use. Next P1 plus P2 equal to 250 based on the two. Okay, I think you got how to calculate this values. Okay. Now I will take the doubt session. If you have doubts, you can raise the hands. If you have doubts, you can raise the hands. Sir. If you have doubts, you can raise the hand. I will allow you to talk. Bhavani.
Good morning, sir. Good evening, sir. Sorry. Hello.
Ask your doubt.
Sir, in hot power, we, as you said, for second, we are making one section hot section. But what is the use of that, sir? Because it's not delivering any power now.
It is not delivering, sir. It is just floating on the bus bar. Because load is not constant, no. Load is not constant. Whenever the load changes, we will load that alternator to meet that requirement.
But if we don't use that, what happens, sir?
That is not in our hands, sir. Whenever the load changes, we should generate the power based on the load condition. No, generation and load should be balanced.
Okay. But we cannot.
If you are not keeping the unit under hot condition, if you want to meet the load requirement, it takes 8 hours. During that 8 hours, what happens? The load will change its characteristic, no?
Yes. We should just generate the power. That's it.
It is just minimum input will be given. Hot condition.
Okay, sir. Okay, sir. That's it, sir. Thank you.
Naga Vinita.
Sir, which materials are used in the construction of fixed contact and moving contact in circuit breakers?
Copper contacts are used.
Copper contacts. Okay. Sir, we are not using hot start in case of nuclear, no, sir?
Yes, sir. Because controlling the nuclear power is difficult. No, nuclear reaction is difficult.
Sir, then why the load curve is constant, sir? Load
because
curve
it is whatever the power that is generating, it is delivering to load, no?
Yes, sir, but the reaction is little bit difficult, you told.
No. Suppose if the nuclear power generator is 200 megawatt, it continuously supplies 200 megawatt. There is no difference.
Okay, sir. Sir, one more thing, sir. Sir, in Buckos relays, the time of operation is very high to control the short circuit faults, no, sir?
No. Buckles relay time of operation will be more when compared to the percentage differential relay.
Okay, sir. Okay, sir. I mean, Buckos really can't sense a short circuit faults, sir, or
It
it
will
can
sense both.
sense.
It will sense both, but the time of operation is more. If you allow short circuit fault for such high time, the winding may get damaged. That's why we will use what a percentage differential relay there. Okay.
So we are using only for interturn faults, sir. Buckos
Only
relay.
for interturn faults, Buckles relay is used. Even when short circuit fault takes place, if a differential relay fails to operate, then it will act as a backup for that.
Okay, sir. Sir, in case of nuclear, which process we will prefer, sir?
That
I mean,
will be
hot
discussed
start.
in fusion in generation topic. You will be discussing that. Now, that is not the issue.
Okay, sir. Thank you, sir.
Okay. Singer,
Good evening, sir.
ask your doubt.
Then question number 2 of CRO.
Question number 2 in this.
Yes, sir.
Which slide?
Sir, 42 or something. 42.
Okay, what is your doubt?
Sir, here IC1 equals to IC2 equals to IC3 equals to lambda. So how we are
This is the
getting
coordinate equation, no, that we have derived.
Yes, sir.
Based on that, I have equated IC1, IC2. These are the incremental cost. No, dF1 by dPg1 is nothing but incremental fuel cost.
Yes, sir, but IC1 is getting in the equation of PG1 and IC2.
That's what the equation. This is a problem framed by the question. No, that is a whoever he is setting the question, he has framed like equation like this.
Yes, sir.
Okay.
Got it. Thank you, sir.
Okay. Srimatya S.
Sir, in last question, sir. If both P1 and P2 did not violate, sir, can you hear me, sir?
What is your doubt?
In,
Both
sir,
P1 and P2
in
are
this
not
question, if
violating the
both
limit.
P1, what will be the lambda value, sir?
Lambda value will be
What is
equal,
the
sir. If
lambda
P1
value?
P2 are limits, P1 P2 are within the limits, then lambda 1 will be same as lambda 2.
Yes.
The next question is that one only. Next question is that one.
Okay, sir. If both the P1 and P2 violates, both P1 and P2 violates the limit,
Then
sir.
based on that
What we have to
violation,
do?
you should set, sir.
Okay, sir. We should equally divide the power, sir.
Not equally divide, based on what condition that is satisfying, we need to see. Generally, this is the first time that I have got that doubt.
Okay, sir.
Okay.
Okay, sir.
Kumar,
Sir,
ask your doubt.
sir, question number 2, sir.
Speak loudly, sir. I am not hearing your voice.
Sir, question number 2, sir.
Question number 2.
3.
Where? Which slide?
Slide. Sir, actually, in solution, I don't have any doubt, sir. But
Number 3.
sir, in
This one,
in CRPU, like you అదే సార్ క్వశ్చన్ లో 1000 రూపీస్ per hour అని మెన్షన్ చేశారు సార్.
1000 rupees per hour. ఇక్కడ
క్వశ్చన్ లో సార్ క్వశ్చన్ నెంబర్ 3 అంటే మీరు లైక్ PDF ఓపెన్
question number 3, yeah. What he has given 1000 rupees per hour, where he has given? I am resharing that, wait. Question number 3, where he has given 1000 rupees per hour.
Yes, sir. Downside, sir, in C1 కింద 1000 rupees per
Okay,
hour.
what is the problem with that? Here he is asking only power generation, no. Why about that? Why you are worrying about that 1000?
We don't multiply with 1000, sir.
That will not have any influence, no. That is the cost. 1000 rupees per hour is the cost. 1000 multiply with 1000. If you are calculating the cost, then that should be taken into consideration. Here cost is not the criteria, no. Are you there?
Yes, sir.
Here whenever differentiating, no, that rupees will not have any influence there. Here we are not going for that cost analysis, no, sir. Here I am not calculating any cost. Even if you write 1000 also, that will not have any impact. 1000 rupees per hour, 1000 rupees per hour, rupees per megawatt hour. You should equate those two. Both sides 1000 will get cancelled out. Now why you are getting so much? Here, whenever you are equating on the both sides, it will get cancelled. No?
Yes, sir.
Okay.
Yes. Thank you, sir.
Right. Venkatesh, Aishwarya.
Hello, sir.
Ask your doubt.
The zonal protection scheme ఆ టాపిక్ లో ఓవర్ రీచ్ అండర్ రీచ్ ప్రాబ్లమ్ ఈ స్కీమ్ ద్వారా రెక్టిఫై చేయొచ్చు అని చెప్పారు కదా సార్. ఎలా సార్?
జోనల్ ప్రొటెక్షన్ స్కీమ్. సో ఇక్కడ మనం 3 సెక్షన్స్ తీసుకున్నాం. ఈ ఫస్ట్ సెక్షన్ అనేది R1 తో ప్రొటెక్ట్ చేస్తున్నాం, సెకండ్ సెక్షన్ అనేది R2 తో ప్రొటెక్ట్ చేస్తున్నాం. ఓకేనా? ఇక్కడ జోన్ 1 ఆఫ్ R1 ఏమో ఫస్ట్ 80% ఆఫ్ ది సెక్షన్, ఇదేమో జోన్ 2 ఆఫ్ R1, ఇదేమో జోన్ 3 ఆఫ్ R1. ఓకే, ఈ R2 ఇదేమో జోన్ 1 ఆఫ్ R2, ఇదేమో జోన్ 2 ఆఫ్ R2. ఓకే, సో ఇక్కడ ఫాల్ట్ ఎప్పుడైతే ఈ ఫస్ట్ 80% లో అక్కర్ అయిందో అది R1 సెన్స్ చేస్తుంది, R1 జోన్ 1 సెన్స్ చేస్తుంది, ఆపరేట్ చేస్తుంది, నో ప్రాబ్లం. ఓకే, బట్ ఇక్కడ ఎప్పుడైతే ఫార్ ఎండ్ లో అక్కర్ అయిందో అది అండర్ రీచ్ వల్ల ఆపరేట్ కాలేదు ఇంతకు ముందు. కానీ ఇప్పుడు ఇది ఏ జోన్ లో అక్కర్ అవుతుంది? జోన్ 2 ఆఫ్ R1. సో సెన్స్ చేస్తుంది, ఆపరేట్ చేస్తుంది. ఓకేనా? సో F3 sensed by R1 previously, overreach.
Yes, sir.
But now also it is sensed by both R1 as well as R2. But here zone 2 will be with a delay. Okay. Here zone 1 of this will be with a instantaneous.
Okay.
First ఏది ఆపరేట్ అవుతుంది? R2 ఆపరేట్.
ఓకే సార్.
ఓకే
సార్, మళ్ళీ పర్సంటేజ్ బయాస్డ్ రిలే అనేది అవుట్ సైడ్ జోన్ ఫాల్ట్స్ ని అవాయిడ్ చేస్తున్నారు కదా సార్, ఎలా?
అక్కడ అడిషనల్ రీస్ట్రైనింగ్ ఫోర్స్ డెవలప్ చేస్తున్నాం. వీఆర్ డెవలపింగ్ ద అడిషనల్ రీస్ట్రైనింగ్ ఫోర్స్. అడిషనల్ అపోజింగ్ ఫోర్స్ డెవలప్ చేసి రిలే ఆపరేషన్ ని రిస్ట్రిక్ట్ చేస్తున్నాం.
అంటే ఫాల్ట్ ఉన్నా కూడా అది చూపించు.
ఫాల్ట్ అవుట్ సైడ్ ద జోన్ ఉంటే అది అక్కడ ఆపరేట్ అవ్వద్దు. మన డిజైన్ ఎట్లుండాలంటే, సపోజ్ ఇప్పుడు ఈ ట్రాన్స్ఫార్మర్ ని ప్రొటెక్ట్ చేస్తున్నాం మనం, ఇప్పుడు ఈ లైన్స్ ఉన్నాయి. ఓకే, నా ఇక్కడ మనం డిఫరెన్షియల్ రిలే వాడుతున్నాం అనుకోండి. ఈ రిలే ఈ ఫాల్ట్ విత్ ఇన్ ద జోన్ అయినప్పుడే ఆపరేట్ అవ్వాలి. ఇక్కడ ఫాల్ట్ వస్తే ఈ ఫాల్ట్ కరెంట్ ఇట్లా వెళ్తుంది. ఓకే, ఈ రిలే ఆపరేట్ అవ్వద్దు, ఎందుకంటే ఇప్పుడు ఈ రిలే ఆపరేట్ అవుతే ఈ రిమైనింగ్ లైన్స్ కూడా పవర్ లూజ్ అవుతుంది. అందుకనే మనం అక్కడ అడిషనల్ రీస్ట్రైనింగ్ ఫోర్స్ డెవలప్ చేస్తున్నాం.
అంటే ఇది ఈ కాయిల్ రీస్ట్రైనింగ్ ఫోర్స్ ఎలా అవుట్ సైడ్ ఫాల్ట్ ని అవాయిడ్ చేస్తుంది సార్?
అక్కడ రీస్ట్రైనింగ్ ఫోర్స్ డెవలప్ చేస్తున్నాం అని చెప్పినా కదా, అది కన్స్ట్రక్షనల్ గా కాంప్లెక్స్ ఉంటుంది. దాన్ని అంటే డిఫరెన్షియల్ రిలే కన్స్ట్రక్షన్ చూస్తే మీకు అర్థమవుతుంది. అది అక్కడ అపోజ్ చేస్తుంది అన్నట్టు.
ఓకే సార్. మళ్ళీ రియాక్టెన్స్ రిలే అనేది ఎర్త్ రిలేగా యూజ్ చేస్తామన్నారు కదా సార్, ఆ పాయింట్ ఒక్కసారి.
అంటే రియాక్టెన్స్ రిలే క్యారెక్టరిస్టిక్ చూస్తే మనము అది స్ట్రైట్ లైన్ ప్యారలల్ టు రెసిస్టెన్స్ యాక్సిస్ ఉంటుంది. సపోజ్ ఇక్కడ వరకు లైన్ ఇంపిడెన్స్ అనుకోండి, దీనికి మీరు ఎంత రెసిస్టెన్స్ యాడ్ చేసినా దాని ఆపరేషన్ ఏమి ఎఫెక్ట్ అవ్వట్లేదు.
ఓకే సార్.
అంటే ఆపరేషన్ ఆఫ్ రియాక్టెన్స్ రిలే is independent of resistance phasor.
Yes sir.
Whatever the earth resistance it may add, it will not have any influence. That's why you can use it as what? Reactance relay. So reactance relay can be used as earth relay.
Okay sir. సార్ ఇంకొక డౌట్ సార్, మళ్ళీ డిఫరెన్షియల్ రిలేలోనే డిసిమిలర్ మ్యాగ్నెటిక్ క్యారెక్టరిస్టిక్స్ కి అవుట్ సైడ్ ఫాల్ట్ ఈ 2 పాయింట్ కి ఏం రిలేషన్ ఉంది సార్?
అర్థం కాలే అమ్మా. డిసిమిలర్ మ్యాగ్నటైజేషన్ క్యారెక్టరిస్టిక్స్ ఉండడం వల్ల ఏమవుతుందంటే, సపోజ్ ఇఫ్ యూ అబ్జర్వ్ ఫ్లక్స్ అండ్ మ్యాగ్నటైజింగ్ కాంపోనెంట్ ఆఫ్ కరెంట్, సో సపోజ్ ఇఫ్ CT1 saturates for this current IX, అక్కడ CT2 అనేది ముందే సాచురేట్ అవుతుంది అనుకోండి.
ఓకే సార్.
ఏమవుతుందంటే ఫాల్ట్ బయట ఎక్కడ అయినా కానీ ఈ డిఫరెన్స్ ఆఫ్ కరెంట్స్ రిలేలో ఫ్లో అవుతాయి. ఓకే,
ఓకే సార్.
డ్యూ టు దిస్ difference of saturations that will result in current to the relay, and relay operates even when the fault is taking place outside the zone. Okay,
outside the zone అంటే ముందే సాచురేట్ అయిపోతే అవుట్ సైడ్ ద జోన్ ఉన్నది కూడా
అవుట్ సైడ్ ద జోన్ లో వచ్చే ఫాల్ట్ ఆ సిటీని సాచురేట్ చేస్తే ఆపరేట్ అవుతుంది అని మీనింగ్ అక్కడ.
సార్ మళ్ళీ ఇంకొక డౌట్, రెసిస్టెన్స్ గ్రౌండింగ్ లో అన్ప్రొటెక్టెడ్ అని చెప్పి ఒక పాయింట్ చెప్పారు. మరి దానికి ఇప్పుడు ఏం చేయలేమా సార్? అంటే మోర్ నంబర్ ఆఫ్ టర్మ్స్ ఉన్నప్పుడు ఫాల్ట్ అక్కర్ అయితే
సర్టెన్ అది ఓన్లీ రిస్ట్రిక్టెడ్ ఎర్త్ ఫాల్ట్ లోనే మామూలు డిఫరెన్షియల్ రిలే దాన్ని సెన్స్ చేస్తుంది.
అర్థం కాలేదు సార్.
అది ఓన్లీ రిస్ట్రిక్టెడ్ ఎర్త్ ఫాల్ట్ రిలేకే ఆ ప్రాబ్లం. మామూలు డిఫరెన్షియల్ రిలే ముందు చూపెట్టాం కదా, పర్సెంటేజ్ డిఫరెన్షియల్ రిలే దాన్ని సెన్స్ చేస్తుంది.
సో లాస్ట్ వన్ సార్, రియాక్టెన్స్ రిలే అండ్ దాన్ని అంటే స్టార్టింగ్ యూనిట్ తో అది మోర్ రిలే అని చెప్పి ఒక పాయింట్ చెప్పారు. ఆ పాయింట్ ఒకసారి రిపీట్ చేయండి సార్.
రియాక్టెన్స్ రిలే లిమిటేషన్స్ ఓవర్కమ్ చేయడానికి మనం ఏం చేస్తాం అంటే దానికి స్టార్టింగ్ యూనిట్ గా మోర్ రిలే యూజ్ చేస్తాం. మోర్ రిలే క్యారెక్టరిస్టిక్ ఏంటి? సర్కిల్ పాసింగ్ త్రూ ఆరిజిన్. So this is the set reactance. So this is the set impedance of the more relay. Unit 3 అనేది more relay ఆపరేట్ చేస్తాం. అదే యూనిట్ 1 యూనిట్ 2 రియాక్టెన్స్ రిలేనే ఉంటుంది. ఓకేనా? అయితే ఇప్పుడు దీని ఆపరేషన్ అనేది ఈ సర్కిల్ లోపలనే డిఫైన్ అయిపోతుంది. ఎందుకంటే యూనిట్ 3 సెన్స్ చేయండి యూనిట్ 2 యూనిట్ 1 ఆపరేట్ చేయకుండా అక్కడ కండిషన్ డెవలప్ చేస్తారు.
అంటే ఇలా
ఇప్పుడు ఆటోమేటిక్ గా డైరెక్షనల్ అయిపోయింది.
డైరెక్షనల్
అదే అదే మోర్ రిలే ఆటోమేటిక్ గా డైరెక్షనల్ రిలేనే కదా.
అంటే ఇప్పుడు జోన్ 1 రియాక్టెన్స్ రిలేగా
జోన్ 1 రియాక్టెన్స్ రిలేగానే ఆపరేట్ అవుతుంది. జోన్ 2 కూడా రియాక్టెన్స్ రిలేనే ఆపరేట్ అవుతుంది. ఇప్పుడు జోన్ 1 జోన్ 2 సరిపోతాయి దీని లైన్ ప్రొటెక్ట్ చేయడానికి. ఏసనా ఇది జోన్ 1 నెక్స్ట్ ఇది జోన్ 2 ఈ లైన్ ని ప్రొటెక్ట్ చేయడానికి జోన్ 1 జోన్ 2 సరిపోతాయి. ఓకేనా?
ఓకే సార్.
ఈ జోన్ 3 అనేది ఈ లైన్ కి బ్యాకప్ గా యాక్ట్ చేస్తుంది. ఓకే
ఓకే సార్.
Zone 3 will back up the second section, not the first section. Zone 3 అనేది మనం అంత అవసరం.
సార్ లాస్ట్ ఒక గ్రాఫ్ చూపించి యాంకిల్ పాయింట్ దగ్గర ప్రొటెక్షన్ సర్క్యూట్ అదే కరెంట్ ట్రాన్స్ఫార్మర్, సాచురేషన్ పాయింట్ దగ్గర మెజరింగ్ కరెంట్ ట్రాన్స్ఫార్మర్ పాయింట్ సార్ చెప్పండి. ఎందుకు
హియర్ యాంకిల్ పాయింట్ అండ్ saturation point I have considered. Okay.
Okay, sir.
So I have said that measuring CT is to be designed to operate at saturation point. Once it crosses its rated current, it should go to what region? Saturation region. Why? Because the fault current should not reflect on this meter side. If the fault current reflects on the meter side, the meter is getting damaged. Okay.
సాచురేషన్ రీజియన్ కంటే ముందు తీసుకుంటామా సార్?
అంటే ఇక్కడ ఒక పాయింట్ కొద్దిగా ముందు తీసుకుంటాము కాబట్టి ఎప్పుడైతే ఫాల్ట్ కరెంట్ లోకి వెళ్తుందో సిటీ కోర్ సాచురేట్ అవుతుంది. సాచురేట్ అయినప్పుడు సెకండరీ సైడ్ కరెంట్ ఏం ఇంక్రీజ్ అవ్వదు, ఇంకా ఫ్లక్స్ చేంజ్ అవ్వదు కదా.
ఓకే సార్.
కానీ మనం ప్రొటెక్షన్ సిటీ ఏమో యాంకిల్ పాయింట్ లో డిజైన్ చేయాలి. ఎందుకంటే రిలే ఫాల్ట్ ని సెన్స్ చేయాలి. ఇక్కడ ఫాల్ట్ కరెంట్ అనేది రిఫ్లెక్ట్ అవ్వాలి ఇక్కడ. సో ఫాల్ట్ కరెంట్ పెరుగుతున్న కొద్దీ సెకండరీ సైడ్ కరెంట్ కూడా పెరుగుతుంది, రిలే సెన్స్ చేస్తుంది.
ఓకే సార్, అంతే సార్. థ్యాంక్ యూ సార్.
ఓకే. భానుప్రియ దర్శని ఎస్.
Sir.
Ask your doubt.
Sir, today's class first problem, sir.
Which slide?
Before load curves, I do not know the slide number.
Load curve.
Hi, sir. Before this, sir.
This one?
No, sir. First problem, sir. Before load curve slide, sir.
This one only?
Hi, sir. In the slide, next slide, sir.
Huh?
Next slide, sir.
Okay.
Sir, here we are average load we are getting in terms of kilowatts, sir.
Okay.
And demand for
Maximum demand is in terms of megawatt, sir.
Maximum demand is in terms of megawatt. Huh?
Megawatt.
Okay, sorry. I think here it is megawatt, I think, because here you should convert this to here. I think here you'll be getting this in megawatt because 10 power 6, no? Here.
Okay, sir.
That here also this will be converted to megawatt. So
Okay,
that
sir.
will be getting in megawatt.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Mohammed Mubin.
Sir.
Ask your question.
Sir, base load plant means should we choose for nuclear or?
Base load plant means suppose if you observe the load curve variation with respect to time, this is the load curve. So, okay. So the load which exists for the entire duration of this load curve, this is known as base load. Okay.
Okay.
So other portion is known as peak load.
Okay, sir. I mean, I'm asking in the question which of the following is base load means we have both thermal and nuclear.
That aspects depends on the type of generator, that is a hydel plant or thermal plant or nuclear plant, that decides here. But that you will be discussing in generation topic. Okay.
Sir, one more, sir. Sir, this arc restriking voltage is equal to K1, K2, Vm sin phi is there now?
Not as arc restriking voltage, that is active recovery voltage.
Active recovery. Sorry, active recovery voltage. Sir,
just a minute, sir. So there is an announcement from management side. Tomorrow, those who are having digital classes, okay, digital class 7 a.m. to 10 a.m. Those who are already taken, tomorrow will be the last class. That is from 7 a.m. to 10 a.m. Okay, those who are already getting the digital class, tomorrow will be the last class, and the timing is 7 a.m. to 10 a.m. Okay. Okay, that is active recovery voltage. Someone is asking doubt. Okay.
Okay, sir, that K2 constant first pole to clear factor.
Okay.
That I didn't get.
K2 is first pole to clear factor. It is 1 for grounded faults. If you take the grounded fault, its value is taken as 1 because the maximum voltage experienced by the breaker is Vm and the system maximum voltage is also Vm in case of what grounded faults. And it is taken as 1.5 for ungrounded faults because the maximum voltage that the pole which is clearing first is experiencing 1.5 times Vm and the maximum voltage of the system is Vm.
Sir, that 1.5 how I got, I understood, but the terms pole to clear means what, sir?
First pole to clear means out of 3 poles, first pole which is clearing first. Pole means the breaker pole only, contacts. First pole which is operating. That is the meaning of that. Okay.
Sir, one more.
Clear?
Sir, in restriking, sir, one more. Yeah, it's clear.
Ask your doubt.
Sir, in restriking voltage. Sir, in restriking voltage and prospective voltage, we have LNC terms now. LNC. Sir, up to what
okay,
point,
what is your problem?
Sir, prospective voltage is equal to I into under root L by C.
Okay.
Similarly, restriking voltage is equal to 1 minus cos T by under root L by C.
ARB into 1 minus
under
cos
root
T
L
by
C.
root L.
So,
okay, what is?
Yes, sir. Sir, that L and C up to what point, sir? Or
Up to
we
that
should take
breaker
directly from
location.
question whatever it is.
Up to that breaker location.
From
Up to that breaker location, sir.
from what?
From the source side.
From what point?
That breaker location.
From
That's
source
why, from
to
the
the
source to that breaker location.
Okay. Sir, one more, sir. Sir, we have that we have taken that resistance to overcome one problem.
What you are saying?
Sir, 1 second. Sir, that current chopping problem.
Okay.
In that the parallel capacitance is formed. So we have connected a resistance parallel to that circuit breaker.
So we are connecting a spark gap arrangement and resistance.
Sir, if resistance equal to infinity, we have
Resistance infinite means you are not connecting any resistance. That is
undamped. Sir, here we have spark gap means it is also open circuit.
No, that spark gap will conduct for 80% of that spark or voltage.
Sorry, sir.
So instead of conducting between the contacts of the circuit breaker, here these contacts are being conducted. Here you cannot say resistance is infinite. With respect to that voltage applied, the conduction takes place between these two contacts.
So basically, spark gap means what?
Spark gap means two electrodes separated by a distance, so that whenever a specific voltage is applied between those two contacts, that will conduct. And whenever the voltage decreases below that point, automatically this gap gets disconnected.
Okay. Okay, sir. Thank you.
Okay. Right. Today we will wind up here. Tomorrow we will continue.
Sir, your mobile number.
If you have any doubts, you can send it to this.
Sir?
What is your doubt?
Sir, the same doubt, sir, in this question, sir.
What question?
Sir, 6 step, sir.
What is your doubt, sir?
In 6 step, you told that it is AL is in terms of megawatt, no, sir?
I think this one you will get in terms of megawatt here.
No, sir, we are getting in. If we take it in megawatt, we are not getting the answer, sir.
You take it in?
Sir, if you are considering it in megawatts, it is coming as load factor is 0.00351, sir.
No. Here, what the problem is? Actually, this is 61.5 into 10 power 3. That is kilowatt. No, here we should remove that 10 power 3. Then you will get this megawatt.
No, sir, I cannot understand, sir.
I will repeat this question tomorrow. Okay, I will check that from the source and I will check.
Okay, sir.
Okay.
Sir, మార్నింగ్ 7 to 9 డిజిటల్ క్లాసెస్ అన్నారు కదా సార్, అది ఆల్రెడీ అయిపోయిన వాళ్ళకి లాస్ట్ టాపిక్ లేకపోతే ఆల్రెడీ నడుస్తుందా?
ఆల్రెడీ ఇప్పుడు ఎవరికైతే అవుతుందో వాళ్ళకి.
అంటే మాది ఆల్రెడీ 1 month అయింది సార్, అది కాదు కదా సార్.
ఇప్పుడు ఆల్రెడీ మార్నింగ్ కొంతమంది స్టూడెంట్స్ కి ఆల్రెడీ అవుతుందట కదా క్లాస్.
ఏమో సార్, తెలియదు సార్, అందుకే అడుగుతున్నా.
వాళ్ళు నాకు చెప్పింది ఏంటంటే ఈరోజు ఏదో క్లాస్ క్యాన్సిల్ అయిందంట మార్నింగ్ పవర్ ఇష్యూ వల్ల.
ఓకే సార్, అర్థమైంది.
అది రేపు క్లాస్ ఉందంట, అది 7 to 10. ఓకేనా?
అంటే ఐ థాట్ సమ్ ఆఫ్ ద మిస్సింగ్ టాపిక్స్ ఆర్ గోయింగ్ టు డిస్కస్.
నాట్ లైక్ దట్. ఐ థింక్ they have said that today's class was cancelled due to some power issue that is scheduled tomorrow.
Okay, thank you, sir.